And I also wrote a little compiler that took like GLSL, like simple expressions, make a little compile tree. And then I did like in ML, you do backpropagation, gradients, training. So they wanted like a differentiable renderer thing. So they were like, can you check your code? I'm like, sure, where can I check it in? They're like, well, you got to pass review. I'm like, well, there's like 10,000 lines. And they're like, how'd you write 10,000 lines in like 3 weeks? I'm like, you can write a lot of lines if no one's like complaining about how many lines you're writing. This is like the first Move controller prototype, and it's a ping pong ball. I don't want to rip it apart, but there's that actual LED inside. I was pitching people like, hey, we can port like PC games because we have like the precision of a mouse. I actually had a prototype where I ported where I had Move tracking working to do StarCraft.
So can we start a little bit about your background? Maybe tell, how did you start programming, your programming journey?
Yeah, I mean, I played games like forever, and I think probably for every game that I played, I always like open the level editor and seeing like, oh, how do I, like almost before the game, it was like back in the DOS days, you didn't have like a launcher, right? So you like go in the folder and you see like all this stuff, right? And it was kind of, and you see like the game.exe, and it's like always 8 less. And there would be like an edit exe. I'm like, yes, edit exe. So I'd click on that first, and then it'd be like, all right, cool. And then I'd play the games. So I like always liked the editors and things. And then I think around like StarCraft days, there was like simple scripts and you can do mods. And so I would do like mods, and I did like mods for StarCraft and Warcraft and Half-Life. And so I actually didn't get into like proper programming till pretty late. I mean, I had actually, so I grew up in Russia. I was born in Russia, and like I think in 4th or 5th grade, we had like a lab class, and I think it was like in BASIC or some Soviet variant thereof. And I remember like it was like 40 minutes programming, and then the last 10 minutes they just let you use the computer for like however you want. And of course we'd play like Mortal Kombat, like a pirated version of Mortal Kombat. And so mostly we just waited for that part, right? But like during the other part, we'd like program. And so I remember like doing pixel graphics and like loops or whatever. So like, but I never got like very into it unless it was attached to games. So I think scripting is kind of where I got more into making real things and like calculator games in school. And so, but then after high school, I didn't like do super well. And then I was like, yeah, I really needed like a proper job. And so I like went to, I was like, I'm going to do programming. And so, because I was always like pretty decent at math. And then so I went to community college, and I transferred to Berkeley, and I sort of got my act together. And that's when I started like properly learning programming. And so I sort of went deep on that. And I also just like didn't understand the administrative structure of college, like that you had to plan your courses. So because I was coming out of high school, I was like kind of slacking because basically Russian school is like really difficult. So we moved to America. American school was like really boring. So all I did was play video games and like coast on the knowledge that I had from Russian school. Because I literally didn't do any new math. Like I came when I was in 5th grade. I didn't learn anything math new in America till I was like 11th grade or something. Like there was a gap. Like we were doing like trig in 5th grade. And so I just like coasted really hard. Like I should have probably sort of not done that. But as a kid, I'm just like, well, I'm passing all the tests, and I'm just like, whatever. And so like that was problematic because I didn't do anything but the tests. So I was like, anyway, this is like off topic. Anyway, when I got to Berkeley, my thought was like, all right, well, I'll just do like all the hard classes. And so like I just took as many classes as I could for forgetting about the grades. And so I was just like, took all the hardcore CS and theory stuff. And so, and then I got a lucky break from my graphics professor because I was making like toy games in my graphics class. And he introduced me to the Sony PlayStation research department, which is like it was in Redwood City at the time, like nearby. And so I took an internship there working with Rick Marks, who was doing like iToy and all sorts of experimental games for PlayStation 2 and later 3. And so I joined that group as an intern, and I just like did physics projects and did like, novel games using cameras, using the wall controllers and whatever. And so after the internship, they're like, yeah, you should like stick around.
Nice.
So they gave me a job offer, and so I stuck around in that group, and that's kind of how I landed in PlayStation R&D, just like sort
Nice.
of fresh out of
When
Berkeley.
did
Yeah.
you start learning C or C++? plus plus?
That was actually so I don't know how it is now, but Berkeley used to
Yeah,
start you with
yeah,
like
yeah, yeah.
Scheme, which is like a Lisp variant, and then they walked you backwards towards assembly, which I hated. I was like, assembly is the thing that makes sense because I'm like, this is how it's actually doing it. But I mean, I know why they do it because they sort of want you to think about computing. So like, I don't know, but basically, I learned C kind of at the last tail end of the Berkeley education, and then obviously PlayStation. So when I joined Sony, PlayStation 3 was sort of in the middle of its life cycle, and so everything was C++. And the Sony SDK, I believe, was all in C because that's just, traditionally PS2 was, and just like the low level SDKs were in C. There might have been like some C++ wrappers in here, and then uh, yeah, I'm pretty sure some parts had to be C. I don't actually remember super well, but it was definitely C++ at least. And so yeah, there's not like a lot to learn in C, so it's kind of good because we did like I think the final course at Berkeley, you do C and then you write like an assembler in C, and I take compilers before, so I was like pretty comfortable by then. So I guess the education progression worked because I was like, oh, C, it's just another thing. And so I didn't write it in any particular way. I just sort of wrote it in the obvious way. So I kind of I we did do Java, so I had some of the object oriented
Virus.
virus in me, but like it didn't take too hard. And then being hit with like low level, uh, I later found, I think from experience, I don't know if this is exactly true, but my perception is like Sony is the more low level one of the two between Sony and Microsoft. I don't know, maybe Microsoft people will kind of like shade me for that, but like I think Sony being a hardware company, they're very like C centric, and so all the developers were always very like there was never that much interest in the high level C++ stuff. Whereas when I talked to people from Microsoft, I was like, you guys write code this way? This is wild. Like I thought we developers don't do this. And they're like,
When you
no,
say
we use
don't do this, maybe it might be useful for the audience if you say like what would be exactly the
oh
differences?
yeah. Well, I remember like I wrote some code that was like a prototype for a game, and I sent it over to London Studio, who was like they were working on iPad at the time, and I thought my code was like woefully simple, like it was just structs with some functions, and I was kind of embarrassed, because I was just starting out, and I was like, hey, I wrote this prototype. I know it's not how a real game is written, but like let me know if this works. And they're like, oh my God, this is so good because everybody's now is writing all this BS. And by the BS, they mean like virtual inheritance of this and like deep hierarchies, and like this object sort of inherits traits of this and this and this. And that, so that was helpful because that was like a real studio telling me like, no, actually like the simple stuff you're doing is actually good. So then I kind of ignored all that other stuff. But then, so that was before like everything went super modern with the smart pointers and everything. And then yeah, that never really took off, at least at Sony when I was there. So like all of the automatic memory
Okay.
management and containers, like we never used the standard library. You don't use the standard
Yeah, especially
library.
if
Like
you're
that
coming
kind
from C,
of that's yeah.
like C background people, they're used to writing their own data structures. They're like, why would I use C++ standard library? Like I can do these
Yeah.
things myself and I will write them and I will know exactly what is in there and I will don't need to like read the stuff.
Yeah.
So mm,
Yeah. And I mean now it's sort of like a meme, right? Like game developers write everything. But realistically, at that time, it comes from a real trauma, right? And at that time, uh, the standard library implementation is not guaranteed to be well. It's not guaranteed to be correct for one. So like, and then the depends on the compiler or whatever, right? And so real game developers hit real bugs and real differences between platforms using the standard library because of the way it compiles like on Xbox versus PlayStation. And like when you're trying to make sure your game runs well, you don't want it to be that, hey, like the Microsoft version of standard library, because they're using a compiler from their MSVC, whatever, it's super different from the Sony, what I forget, PowerPC backend. And so just as a developer, you don't want to be like hunting the same bug or performance optimization twice. So it's not even just sort of like, oh, I'm allergic to libraries. It's like, no, like really, I'd rather have a code piece that I know because it will literally save me time when we're shipping this thing. So that's where it sort of, I think, comes from. Now it's less of a thing. So I think there's a bit of momentum of just not doing it. But like back then, it was a real problem, not a sort of ego.
That's wild that you can have such differences. But that's maybe because you also have a lot of platforms, right? And there's a lot of like the compilers work differently in different platforms.
Yeah, and I think PS3, the CPU was particularly finicky. And so if you like all the things that were not so bad that the standard library might do, you had to just kind of avoid them. They're not necessarily like bad things, but you really wanted to make sure like like the standard library vector grows on its own, right? And there's like a growth factor, and that's not specified. Like you don't know if it's going to double every time in size or if it's going to like 1.5 or whatever, right? And so if on one platform, like the growth factor is set one way, and this is just an example, I don't know if this is actually the case, but it could very well be that like because of memory allocation speed or whatever, you really care that because one platform is particularly bad at it. So I think now that's much less of a problem. But there's other problems. Memory is still a problem. Cache is still a problem.
So you said sticked around near Sony, and you worked on technology called PS Move, right? PlayStation Move. Can you talk a little bit about that?
Mm-hmm. Yeah, so when I joined this experimental tech group, and so our mission, so we were inside Sony research and development, and particularly we were like the novel experiences and interactions group. So we would, we submitted stuff to like the experimental games workshop back in the day when that was like doing really wild stuff. And so we worked with cameras, offbeat input devices like, like skin galvanics, like heartbeat detectors, different haptics. So it's like a cool place because a bunch of people would show up and they would say, we've got this new input technology. Like, are you guys interested? And that was also started the beginning of the era of like the Guitar Hero Wii era where peripherals were like a big part of console gaming, where you had all sorts of interesting ways to interact. And so we were like, there was a lot of work to do. And so when the Wii came out, it was like obviously super popular at that time, and it was like blowing everybody else out of the water. And then naturally people would come to us and be like, hey, don't you guys want to do a motion controller? Like, and so later, as we well know, like Microsoft did the Kinect controller, Sony did the Move controller, but actually like the PrimeSense people that did the Kinect worked with Rick Marks like for years before there's demos of him working. And there's even a game called iToy Kinetic, which was like very reminiscent of Kinect later, which they helped on, whatever. So there was like a lot of chat with those groups. And so me, Rick, and other people were kind of in charge of figuring out what do we do with the kind of motion gaming strategy. And I was like, freshly employed, but they were just like, hey, you talk to all these people and you figure out which one of these is good. Like, should we do the camera, or should we do like some kind of controller? Because Sony was like not, I don't know, they were like in two minds. I don't know, I'm not going to speak for Sony, but sort of just like the vibe I got was like, obviously Sony's core business is like the traditional gaming, but they wanted someone to look into this motion gaming and see what's good. And so we looked at all these technologies like magnetic and acoustic tracking and all this stuff. And then we had internal tracking tech from the PlayStation 2 days where, we had the camera on PlayStation 2, the iToy, and we did some experiments where you hold up like a big yellow ball or something, and it would track it, and you can do games around it. And so I was like, hey, why don't we like just do this? Why don't we just track like a stick with a ball on it or something? What's the problem with that? Like, why is that worse than like the acoustic and magnetic trackers that these people are bringing us? And Rick's like, well, it wasn't very robust with lighting and stuff. And so I was like, well, why don't we just put like an LED into it, right? Because then it'll just be always bright. And he's like, okay, well, that's a good idea. But then what happens if like there's big green poster in the background? Like you also have to remember, like right now we have like machine learning, vision tracking, and self-driving cars. Back then, like tracking anything was sort of a pain in the ass, basically. And so the color tracking back then, especially on the consoles, was like very primitive compared to today. So we were worried about stuff like, oh, it's a yellow ball, but like someone has a yellow poster on it, or like a yellow smiley face, which looks like a ball, and then now it's like totally confused, right? So it's a very different time. So I was like, okay, well, why don't we put like a color changing LED, because those were becoming like cheap at the time. And then we'll like look at the color of the background, and then we'll change it to whatever's not in the background. And Rick's like, oh, that's kind of interesting. And he's like, just make that. So I did actually. I have it right here.
Nice.
This is like the first Move controller prototype, and it's a ping pong ball. I don't want to rip it apart, but there's that actual LED inside, and I think this used to be where the IMU, the inertial measurement unit, went, and it's like a piece of Home Depot PVC pipe, which is like a hardware store in the US. So I went to the hardware shop and like bought the bits, and I went to like a local electronics shop, and because I had like electrical engineering and CS background, I just sort of like wrote the firmware,
Nice.
soldered the thing. I got kind of told off for soldering in the office because you're not supposed to apparently solder in the office. So we made this thing, and then I first tested it manually. We'd like put colors up, and I'd change the color, and like, look, it still tracks. And we're like, oh, this could actually potentially work. And so we pitched to Sony like, hey, we evaluated all these technologies, but we think this one has legs, and it uses our existing kind of camera technology and legacy. And so it sort of also looks good from a continuity perspective. Like, we've been doing this kind of thing, and this is the next evolution, blah, blah, blah. And so they were like, yeah, this seems good. And so we had this big meeting. And I remember that's when I first, I met Mark Cerny, because he was like a consulting person, like famous consulting person for Sony. And he was the one person in the room who's like, this can't work. And I was like, why can't it work? And I didn't know who this person was. And he's like, this won't work because there's not enough pixels in the image. And I was like, okay, somebody's like paying attention, because he's like very smart. And so he, like, while we were all chatting in the back of the room, he like worked out on paper sort of what the tracking accuracy would be, like back of the napkin,
Nice.
based on the number of pixels in the camera image and the size of the ball. And he's like, according to this, when you try to do the tracking, even if you're accurate to a pixel, it's going to move by like 5 centimeters or something. So it's going to be completely unusable. And I was like, I didn't know who it was. And I was like, well, that would be true, but we track to 1/10 of a pixel. And so you're incorrect. And everyone's like, I was like, you just told me. And I was like, I don't know who this person is. so we kind of, we got along after that, I think, because he was like, okay. So and afterwards, he came to me, he was like, what are you talking about? So I explained to him like how this is all going to work. And we had a good relationship after that, but it was kind of
Intense.
a fun moment. Yeah, but that's why he's really good at this stuff, because he's like one of the people that really like pays deep attention when you talk to him, and like, because some people you talk to and they're like, and they ask a question, but he's like running the calculations in a separate thread. And then if something like doesn't work, he just tells you, and you're like, what? And so you have to just dive down. And so it turns out that like, even with basic algorithms, you can get to like 1/4 of a pixel. But he was right. The math is like really abysmal. Like the iToy was 320 by 240. This new camera was 640 by 480. So, that's not a lot of pixels. And the ball, like, it was like the final controller. And the ball, if I remember right, is like 45 millimeters. And so obviously, like in this camera image, right? If it's this close, it's like, no problem. You can kind of easily track it. But people don't play at that range. They kind of play more out here, right? So even like on a good camera image, you're starting to see, okay, well, it's starting to become small. And then it's like, well, the lighting is affecting it. It's got this like big lint on it and so forth. And so it works out that if you play at like a 3 meter range, which is sort of typical for console gaming at that time, you're sitting on the couch like way back, the ball ends up being 4x4 pixels at 640 by 480. So you've got 4x4. And on a 320 by 240 camera, which was what sort of Mark was calculating for, it would have been like 2x2. And so he was like, you're not going to track a 2x2 pixel thing. Like, imagine it's stair steps. And so, and the math is in 2D, like in the XY, you can kind of imagine it's pretty good accuracy, but in Z, the Z is correlated to the size of the ball. So you need to measure the size of the ball really accurately. And so your Z coordinate is 1 divided by the R coordinate, the radius of the ball, right? So it's like inverse proportional to the radius. And if you look at, 1 over X graph, it sort of is this like, steeply sharp thing. And you would know that as R gets like smaller, the graph shoots off like up to infinity, right? And so this portion of the shooting off into the infinity graph, the slope is really steep, which means for every small change in radius, you get a massive change in Z. And so if you're off by like 1 pixel, well, now you're off by like back at 3 meters. And you can imagine like in astronomical units, like if you're really, really far, if the sun's off by a pixel, that could be like millions of miles, right? I don't know, more. Anyway, so the point is, measuring that radius was like the key technical challenge. So that's what I noodled on for like 2 years.
And this was also done all on the integers, right? Like you need to get back to the pixels. The pixels are not. If you do this I wonder whether if you were to do the math on the floating point numbers, you would lose a lot of accuracy, right? And then
the way it works out is like the image is in integers. You get discrete pixels, and they're all 8-bit. So they're just a bunch of 0 to 255 values. It's like a standard camera. But the saving grace is that the image is not truly discrete. Like if you zoom in, you have a little bit of blur in the image. And so if it's like anti-aliasing, right? If you look at like a line, it's not a perfectly crisp thing. And that's why we were able to do anything at all. Because if it was perfectly crisp, then you are literally just counting pixels. And it's like, well, if your ball is 4x4, it's like, well, it's either 16 pixels or 17 or something, right? And then your accuracy is really trash and it's not good enough. But because of that blur, you basically do reverse anti-aliasing, and you look at the shape of the anti-aliased curve and you fit data to it. And that was the secret sauce.
Because can you say it again?
It's hard to do with the. So imagine this. Imagine like because people are probably familiar with anti-aliasing. Let's say you are thinking. Let's say you have like a 4x4 image, right? Really, just to kind of mentally simplify it. And in that 4x4 image, there's a line segment that's like, goes from 0, 0 to 3, 3, right? So it's like a diagonal line. Now let's imagine we want to calculate the coordinate of that, like the endpoints of that line super duper accurately, because we have to track sub-pixel for any of this to work. So it can't just be like 0, 0 to 4, 3, 3 or whatever. It has to be like 0.138 to whatever. So like you're saying, we have to get some kind of floating point sub-pixel value out of it. And that's exactly what happens with anti-aliasing. You have your triangles coming in and they're at sub-pixel coordinates. And then when it gets rasterized, you do stuff and then it sort of blurs it out to multiple pixels. And so that's what makes it look smooth. Well, in a camera, the same thing's happening. Obviously, the sphere is an exact sphere, and then it goes through the camera lens and blur transfer functions and all this. And then it hits the sensor and it's not a precise pixel image. That's because otherwise it would look crap. So you can then look at how it's blurred and you can use that to deduce the subpixel
Oh
information.
wow. Okay.
Um, it's called a deconvolution, sort of in the academia. And so if it was a pure white background with a pure black line, there's actually, if you know the blur function, you can pretty accurately, almost, I think maybe exactly, reconstruct the line. But of course, it's not a pure white on black thing, and so there's stuff, and so it's a lossy thing, but you
Sort of
can
do it.
still do it, kind of. Yeah, and so it turned out that with enough staring at 4x4 pixel chunks and enough sort of pushing things around, I was able to get about a tenth of a pixel accuracy out of it, which was pretty cool. Which meant that, like, in practice, you could imagine, instead of the ball being 4x4, it's now something like 40x40, and now you have quite a lot more accuracy. And so, if I remember right, that put the accuracy down to about like half a centimeter of jitter at 3 meters, and then using the inertial unit, we can sort of stabilize it even more. And that, in the end, that obsession was partly why the Move controller survived into like the VR days, even, because we did it like almost 10 years before VR. But even when it landed in the VR days, it was like good enough to get started with the tracking, right? Like, obviously the newer devices had way more power and horsepower and technology, but like even from 10 years ago, like using the 640x480 camera, mostly it was like obsessing over the pixels and also knowing the hardware of the camera, because we measured the actual hardware. Like, we measured the transfer function of the lens, so we knew exactly how it would blur things. And you can only do that with a console camera, because, and so people are like, why doesn't the Move, why can't we ever, why haven't people done like the Move on PC or whatever? And it's like, well, if you try, everybody's webcam's different. You can't do this trick because you don't control the hardware. And so you can do it, but it can't work far away with a small ball. So you end up having to have a huge ball, and nobody wants a big goofy ball. They already thought even the small ball was goofy, right? So like, so that's like part of the reason. So it was interesting, and all this had to run on the PS3, which had, like, if I remember right, 256 megs of RAM on the CPU side and like another 256 for the GPU. So the image processing budget was 1.5 megabytes. So all the image processing, including getting the images onto the memory, was 1.5 megabytes, like, more or less. So like the size of our entire budget was like less than the size of an image that people typically work with. And so the images would come in, they're 640x480, and they were Bayer patterns. They're not like RGB, they're RGB. Basically, it's like either red, green, or blue for every pixel, and it's a Bayer pattern. That's how real cameras still work. And then you like de-Bayer that. But basically what it means is like one image frame is 300K or something. And so you take that and then you work as much as you can on the Bayer image, which is like this mosaic mess. And then you like de-Bayer it and then do some tracking there. And then, yeah, and everything has to finish in like, obviously a fraction of a second, because, yeah, the tracking has to be real time. So our final was like, I think we took 4 milliseconds on one of the SPUs, and the SPUs were like these coprocessors that like the PlayStation had, and not many, well, the big studios used them because they were into it and they had time, but like many people just didn't use the SPUs, which are like the powerful part. And so when we were doing the tracking, like, we couldn't do it on the CPU because it was like too precious. So we were given a meg of memory and one SPU. It was like our target. And so we
comparatively SPU like was similarly to CPU in terms of power, or is it?
It was actually, I could probably Google it, but yeah, I'm not gonna keyboard type. But I think they were clocked higher than the main CPU, but they were like DSPs, so they were much more low level. Like, you'd DMA some data over to them, you would run some kernels. It was like a bit like a GPU-ish vibe. I mean, SPU aficionados will sort of kill me for this, but it's kind of like it's kind of like something like a DSP, where you send memory to it, you run C kernels on that stuff, and then you do it. And so we used it for some image processing stuff, and we used it for the tracking code. And so that required like pretty low level SIMD, blah blah blah, optimizations to get it running.
And the PS Move, in terms of the product, I think it had like mixed reception, right? How was it from your end?
It's a good question. I'm trying to like so I did a lot of like PR for the PS Move as part of the launch and everything. I have to remember my PR training, because I said some spicy things back in those days, and I got like a bit in trouble because I talked a bunch of shit about Kinect, basically. I still think that the PS Move is the right thing for like something like a 6DoF tracking wand. I think is the right thing for creating gaming experiences. Like generally speaking, I think cameras are cool in their own way, and like I think you can make dance games really well with them and other things. But so much of what we do requires tools, like you want to simulate like a sword or a paintbrush or a magic wand or whatever. And I think that was sort of also played out in VR. Like everybody made some kind of tracking wand. So the actual form factor basically for the PS Move was driven by how can we get the tracking of 6DoF working. And like we literally could not get 6DoF tracking in that era with anything but a giant glowing ball. If we could have done it with some nice like infrared LEDs or something, I would, I have no like deep attachment. Like, and you've sort of heard the story now, is like the way it comes about is like, well, we've got a camera, it's the PSI, and we've got this technology, and acoustic technology didn't work, like ultrasonics, very well. Magnetic technology still didn't and still doesn't, and there was lots of people trying to sell magnetic technology, and that was again sort of proven out by people smarter than I, right? Like Valve also negged on it, and so did Oculus and all these people. And so eventually optical tracking won out, right? And so that was sort of indicated in some sense. But the optical tracking of that era looks like a giant glowing ball is sort of my point. So Mick, I think people that used it really liked it. I mean, I went to conventions and I talked to people, the people that liked it, they were into it. It was interesting from a game design perspective because a lot of people likened it to the Wii, obviously, because that was like popular thing at the time. And maybe even within Sony, people thought of it that way. I always thought of it as like a tracking device. And so I was excited about what would eventually be stuff like Dreams, where I'm like, hey, we can use this precision, because I'm a PC gamer, like coming into it. So I was like, I literally sold, I was pitching people like, hey, we can port like PC games because we have like the precision of a mouse. I actually had a prototype where I ported where I had move tracking working to do StarCraft like on PC. What? So I would like track it on the PS3, and I sent the data over network. And then I wrote like a keyboard and mouse emulator, and I was running StarCraft because I played StarCraft pretty decently, like I was sort of like.
How did you play StarCraft with the tracking device?
So you take the, you take the tracking, which mostly you care about the rotation. It's like basically like a TV remote, right? Everybody's used like these gyro TV remotes. Well, the Move is a much better gyro TV remote. Like it's not quite as good as like the modern trackers, but it's pretty great in terms of rotation. So you take that data, you pipe it into the mouse, and you don't do a pure gyro because you can do a little bit better if you know the position. So you can basically imagine there's like an emulation layer which translates the movement of the Move into a mouse. So now I have a mouse, right, in my right hand. And in my left hand, like if you play StarCraft, you have a bunch of hotkeys because you got like, if you want to play for real, you got to use the hotkeys, right? So I played at like 100 APM, which is like actions per minute, which is like not anywhere near like the pro level of 600. That this is StarCraft 1. StarCraft 2, you can actually play at 100 APM and be pretty decent. StarCraft 1, you needed like probably 300 to be like Gosu. But what basically I could play at 100, and on the left hand, I used the lesser known navigation controller, which was like the analog stick plus some buttons and a D-pad, which was like the Joy-Con, or like the Wii had a similar thing, right? Which you had like a little analog stick. And so the mapping was, trying to remember it. So you have two buttons, an analog stick, and a D-pad. And so I had it like, if you know the
Yeah.
StarCraft build menu, it's like a pie. It's like you hit like B for basic buildings, V for advanced, I think. I'm trying to remember
Yeah.
my muscle memory. And then you have
Yeah.
like a 3x3. And so I said, okay, well, I forget, some of the buttons basically opened the menus, and then I'm pretty sure the analog stick would control which piece of the pie I would hit. So I think it was something like you hit L1 and that would be basic buildings. And then if I just released it, it would select the center point of the
Okay.
grid. So you
Yeah.
imagine, like, have you played
Yeah,
StarCraft?
yeah.
Like, am I making
Yeah.
any sense? Okay. So it's like a 3x3 grid of buildings. And I didn't care about like accessibility. I just wanted to play it. Not even accessibility, but like understandability, right? Like I didn't care how hard it was to learn. I just wanted to see, can I do it, right? So I think the UI was, if you press L1, you're going to build something. And so you press it, and it's like the equivalent of Control B. So like literally imitate Control B. And then when you released L1, it would automatically click the center
Okay.
grid.
Okay.
So you're going to,
Okay.
it wasn't like you open
Yeah.
it. It was like emulation. So you click it. So to click the center piece, you would just hit L1 and you would do it. And if you hit L1 and then you moved the analog stick to like the top left, and then
Okay.
you released L1, it would click the top left thing. So something like that. And so I got good at it. And then you had that. And then I think, interestingly, the analog stick was very good at panning, because in StarCraft, panning was like kind of a crazy thing, because you don't want to pan with a mouse. It's like too slow. So the good players, they would be like doing hotkeys, and then they'd jump to the arrows to pan with the arrows. And it was like, if you watch a keyboard of a pro StarCraft player, it was like really bonkers, because you couldn't remap it to like WASD back in the day. You just had to like play the keyboard. So anyway, I could use the analog stick for that, so emulate the controls. So I got to like
What?
80 APM or something with this, and I was able to, and so I was able to play, and like I played real like Diamond League
I
matches and
can't
won. So
imagine
it's
you
like StarCraft.
selecting with the tracking device like each unit and then casting a spell.
Well, but you don't select, right? So that's the key. So you don't select with the, you never use the pointer always stays on the battlefield. All the UI navigation you just do with this thing. So you do have to get good at like selecting the units with this thing.
Okay, because in StarCraft 1.
But I played Zerg, so Zerg is very macro focused as well. So I won on macro, so I didn't win on micro. So I was like, I also happened to play a race where I'm like, really, I mostly need to make sure I can like I could mass Hydras and win, basically. And I did like a little bit
because
of
it's StarCraft 1, you need to sometimes like select each unit to cast a spell, right? Like in StarCraft 2, you can select.
Not if you're massing Hydras.
Okay, Zerg players. Okay.
Yes, you're right. If you want to be, yeah, but like, yes, you're correct. But so it wasn't. But my perspective was like, coming from PC, I always felt like PC is like where the advanced games are, right? And so my feeling was, okay, we're at PlayStation. If we can just play StarCraft at 80 APM, well, that's pretty good for console people, right? Like, I don't want to sort of be any more spicy than that, but like, that was my attitude, as I was like, well, on console, there are no RTSs. And like, why? Because you can't do that with a DualShock, or you'd have to change it completely. So I was like, hey, like, why can't we have some RTSs on console? And so I actually did a presentation to Blizzard, and I showed them this thing. I did Diablo too, because I was like, look, we should get like Blizzard onto console. And like at that time, I'm like, I don't know, man. Later they put Diablo, I think, on PlayStation, I think, and all that. But I don't think StarCraft ever made it. But it very much could. Like, yes, it would not be the same league, but actually I think if you changed the game a little bit and adapted it so that it wasn't emulated, I think you could actually make a StarCraft-ish game on console with something like a Move controller, or
nice.
Yeah, maybe even the Wii controller.
Good. I'm so happy we didn't skip that. I like, because if I didn't ask about the reception of PS Move, we wouldn't go to the rabbit hole of doing the StarCraft emulation. So
well, so reception wise, okay. So I think like elephant in the room is like it didn't do hype wise as well as Kinect, right? Because Kinect was like camera gaming, etc. And the Wii sold an absolute boatload and just like wiped both systems because this had such a lead and everything. And by the time Move and Connect started kicking up, like already the hype wave was going down. So there was a lot of like macro stuff happening. But I think the thing with the Wii is like Nintendo designed fully around that device, using it, given its strengths and weaknesses, because it wasn't actually nearly as good at tracking as like the Move was, because it was just an accelerometer and they added a gyro to it. But that's like not a shade on them. That the thing is like they designed games purely for that device, whereas like when people designed for the Move, they designed assuming a 6-DoF tracker, and so any kind of issues with precision or anything felt like the device's fault. Whereas clearly on like the Wii, it's like the device was just an accelerometer, and yet the games were. So I think there was like a bit of a developer mindset difference as well. But also what we found was on paper, it sounds like, hey, well, what if you had like a really accurate Wii controller? Wouldn't that make for like a better Wii tennis? And it turned out not really, because there's like this video I remember that was like a dad playing his kid at the Move tennis equivalent and just like wiping the floor with him. The kid's just like really sad and crying because the dad's like, look, finally, like I can beat you at this game because I'm actually good at like the ping pong, but it's not fun because in Wii tennis it's like it's almost random. Like you kind of waggle the thing roughly timed with the thing and like everybody could win. So it's a bit like, kids board games, like you just roll dice and like you have a little bit of an advantage over a kid, but not really, right? But in the Move, like people that were good at ping pong would wipe your floor, like wipe the floor with you if you were not good at ping pong, because the tracking was pretty good. And so that actually wasn't that fun in practice, even though it sounds good from a game design perspective, because like, serious gamers are about skill and stuff. When it came to motion gaming, I think people missed the idea a little bit because they thought, oh, motion gaming is like yet another place where I can display my gaming skill. But actually, motion gaming was more about, hey, I can bring some friends over for a party and we'll just have a good time together. And, the gamers took it seriously. And so I don't know, reception wise, I think there's mixed things in there that are more interesting than like who sold more. But we sold like 15 million of them as well. So like people sort of don't realize it, but we sold a boatload of Move controllers and games. So
and then you moved onto the VR project at Sony, right?
Yeah. So we had some experiments I don't remember the exact timelines, but sometime after the Move, 3D TVs were also becoming big. Becoming big. They never became big, but they were becoming big. And so we experimented with 3D TVs. And one of the demos we did was we actually strapped a Move controller to your head for like really accurate head tracking. And we rendered a 3D, you put 3D glasses on and a Move control. Like we had like, headphones and we strapped a controller to the top of them. And so that was the thing you put on. It's like earmuffs. And because again, face tracking was not good enough for this stuff back in the day. Like it would be jittery. But the main effect is if you can track the head relative to a 3D TV, you can create this sort of fish tank VR effect because you render the 3D image from a asymmetric view frustum. And so you render stereo just like a regular image, but you render the frustum a little bit differently. And the effect is that it looks as if like there's depth inside the TV, like a fish tank. So it's as if you're looking into a fish tank. And there was like a famous video of like Johnny Lee doing this thing where he tracked it using a Wii controller. And so if you do it, it's actually a pretty cool effect. And so we did some games around that where Move controller on head, again, standing in for like, hey, when head tracking is really awesome, imagine what we can do with 3D TVs. Like not literally trying to sell you a peripheral with a glowing ball. But we did that demo, and so you can play games inside the TV and it was 3D. And I did a demo where like you could hold a Move controller and you can like wave a sword into the TV and like stab stuff. So it was pretty cool. People quite liked it, but then they're like, well, there's a glowing ball in your head. And like, yeah, but just like imagine the future when you don't have a glowing ball. And they're like, yeah, but then also like I'm holding the thing here, but then there's like a character holding it in the TV. So that's a little bit weird. Like I'm not actually in the TV. And I'm like, yeah, but like you could do other things. Like you could shoot into the TV and so that was also like a demo I did for Media Molecule where you can create inside the TV, and they quite liked it. So, and that didn't really go anywhere because 3D TVs were just like so niche still. But Media Molecule did do a demo of sculpting inside the TV with Anton Mikhailov, who was like, it's actually working at Adobe as well right now, but that's like some foreshadowing. So that tech kind of became the first prototype for Dreams. Actually, it's like this controllers inside a 3D TV kind of inspired them to do this modeling stuff. But at the time, it was just tech demos, and so later on, another guy in our research department, Jeff Stafford, sort of was really into VR HMDs, and Sony had like a history of HMDs going back way back. They had this like the Glastron and stuff. So Sony's been making HMDs for like TV viewing forever.
HMD shortcut.
Oh, like head-mounted display, like VR. Yeah, so like there's I think it was called the Glastron, and it was this thing you put on your head, and it like had little LED. So I forget what they were, but there's quite small screens. May have been even. I don't think it was OLED back then, but small LCDs or something. And so, but they mostly used it for movies, right? But there was this kind of like VR display tech at Sony. So Sony being like the big Sony rather than the PlayStation Sony. So that tech was floating around. So we had like access to displays. And Jeff Stafford at PlayStation R&D was like, hey, we should try to merge these two things. So he took like that thing and he put the Move on it and he was tracking it. And he was like, now I can actually see it. But the field of view was pretty terrible. And he found there was some people in the UK who were experimenting with similar stuff. And there was a guy that we had on our team. His name's, I think, Ian Bickerstaff, and he was long time into VR. And so he found these lenses. This is actually kind of a wild, interesting story. But there was this guy called, God, I forgot his name. But I think Leap, something Leap. Not like Leap Motion, but like Leap differently. And he made these lenses like back in the 80s or 70s or something. But he made them for TV compression, I think, or some kind of wide. I'm going to butcher this, but I'll try anyway, just because I think it's interesting. So anyway, there's this guy. He makes this lens. And the lens, what it does is, I think he wanted to broadcast like wide field of view, but there wasn't enough pixels in TVs. And so, because he can't so he was trying to do like the equivalent of optical compression. So he's like, how am I going to transmit like a wide 170-degree field FOV image? So he made this lens that took a wide angle lens and compressed it in a funny way such that the corners of the image were more compressed than the center. So now this is starting to sound like modern VR devices, right? Where you render a frame buffer and then you effectively stretch the corners out using the VR optics, because peripherally you don't care about the pixel quality at the corners so much, right? But there's an inverse process where if you want to capture an image like this, you can compress the corners down. And then he would send this optically compressed, sort of squished image over the wire into a regular TV broadcast. And then on the TV, he'd put another lens to uncompress it, right? Now this is starting to sound really familiar for anybody who's worked in VR. And I think this guy was like something Leap. And they were really cool lenses, and they were like aspheric. They were quite advanced, but nobody really knew much about them. And this guy in Bickerstaff knew about them. And he's working with Simon Benson at the time on this stuff. And he came from 3D TV background and all this stuff. Anyway, turns out this guy passed away, and no one knows who this guy is, but this guy at Sony knows. So he goes to the estate sale of this guy, and he finds these lenses. He patented them and didn't sell them because they didn't take off. No one did much with them. He goes to this guy's estate sale. He finds them in the corner of the garage, and he buys them off.
What?
The deceased guy's wife. So we get these Leap lenses, and the patent's expired and whatever. So we shove these lenses into the HMD display, and lo and behold, we have like really awesome compression. Um, and Palmer Luckey was doing similar stuff kind of in his garage, right? At roughly the same time, sort of, again, the universe kind of walking in lockstep. So we get these lenses, and then we shove them on. We put smartphone displays on them like everybody does, and then we put a move controller on your head, and then we have this thing. So I have an image of it somewhere of like somebody wearing this crazy thing. We actually had multiple glowing balls on your head, and then this thing shoved in, and we used a head massager because it was very comfy. You know, these head massagers that kind of go on your head and they do this sort of stuff. But they have a really nice kind of like attachment to your head because they're designed for comfort. So Jeff was like, hey, let's use a head massager. And that's how, not exactly how, but that's partly why Sony traditionally has done like the Halo strap style of HMD, because it sort of came out of this idea of like, how do we make it comfortable, rather than like, I think Palmer had the ski goggles because he was like shoving stuff on his face. So anyway, so we did that. And then, so Jeff did all of that. I didn't have much to do with that, but he was putting a move controller on the head like our old prototypes. And he was like, hey, can you do something better? Because, you know, when I rotate my head, like sometimes the ball becomes occluded and the tracking, can we do the tracking better? Because now we have like a stereo camera on the Nuke. And I was like, yeah, I'll put 3 balls on your head. I was like, that's not. So that was the 3-ball prototype. So I like ripped apart 3 moves and put more balls. And that got us like, but that got us a working HMD that was fully 6-off tracked, which was, this was before like the Valve Room and all this other stuff. So we had like the full 6-off walk around VR working. And so then we showed that to people and people got excited. And then Oculus started coming up too, and more of the general public got excited. So Sony was like, hey, we should really, you know, keep an eye on this stuff, it seems like. So we demoed it at the same time, I think, at E3 as the DK1 was being demoed behind closed doors, I think, to developers. And then naturally people were like, well, we can't have balls on your head. Like, that's crazy, you guys, obviously. And I was like, yeah, of course. And so, and we're like, well, what do we do? And I was like, well, I can like put LEDs on the HMD and make it look decent and still track it. And so that's why the Sony HMD, the PSVR 1 has like the 5 glowing lights on the front and like 2 in the back, because that was the bare minimum I can get away with. And the reason we didn't do IR like Oculus or well, Lighthouse is always seemed like too much of a faff for console players to set up.
Can you talk?
And
Can you
IR
talk
would have
a little bit more about that tech, so that, because I'm roughly familiar with VR, but not to the degree that to understand that. So how does the technology differs?
Yeah. So so for VR you need really accurate position tracking, because you have like the accelerometers and gyros, but those are really only good at tracking acceleration and like radial velocity. And if you integrate those signals to get position, you get what's called drift, because you're integrating you know, a derivative signal, and then you're summing up all the error, and the error kind of bleeds over time and it drifts away. So you can't do it purely with inertial. So you have to have some kind of positional reference. And so what we found was that, what everybody found was that optical tracking of some kind, optical meaning involving light and sensors of some sort of light, seems to be the most reliable. And that's because, just as a brief primer, acoustics, like if you use like ultrasonics, like bats and whales and whatever, like I guess dolphins, sound bounces, and then it's hard to reconstruct where the bounces are coming from, and there's noise. If you use magnetics, which is kind of the other thing, for one, people are sort of skittish to put magnet things on their head, like whether that does anything or not, like that's just the truth. And also soft metals around you, like pieces of your desk, and in high-rise buildings, the steel rebar play bad with magnetic tracking. It kind of warps the magnetic field. So we couldn't do that. So everybody, including Valve and Oculus, settled on some kind of optical method. And so Oculus, because Oculus made infrared cameras with infrared LEDs eventually. The first version, they were just rotational. Like the DK1 prototype was purely rotational. We never had a purely rotational prototype at Sony because we were coming from a place where we already had the move controller and it gave us position. So we're like, And we tried it without position. Everyone got sick. We're like, well, clearly this doesn't work. Like you have to have position. So we did position from the get-go, and then Valve did cameras facing outwards and then a bunch of stickers plastered on the wall, like AR markers. And that's another way of doing it. And then later they developed the lighthouse technology, which are these laser sweepers, like these little motorized spinning things that you put in the corners of your room, and they sweep lasers over your room, and little sensors on the headset notice the pulses of lasers. And there's some really clever and complicated math of how to get those pulses, get a position out of those pulses. It's like GPS-ish, if you want to. Again, don't kill me here. I'm simplifying the tech, but effectively, you're getting lasers swept on you, and then the sensors are noticing when those are happening, and there's like a coding in there. So light is the thing because light doesn't bend on our human Earth scales, and so it's very straight, very predictable. The only problem with light is that it doesn't go behind you and stuff, so you end up having to put sensors in enough places. So those were like the technology options. And honestly, if we had no prior tech, I would have also done infrared because you can't see the lights. It allows for a more elegant industrial design. But because we already had, millions of stereo RGB cameras, we didn't want to be like, hey, PlayStation 4 gamers, like, here's a new camera you can buy, which, is part of the HMD package. I mean, the camera, these things are extremely price sensitive, right? PSVR outsold like all the initial headsets. I'm not trying to like brag or anything, but I think it was all like 5 million compared to like sub-million on all the other ones. And honestly, like quality wise, it's probably the weakest of the bunch. Like I think tracking wise, it's weaker. Optically, I think actually has some strong suits even over the other more expensive competitors. We can kind of get into that later, but because of the Leap optics, it actually has like a really wide sweet spot, and there's some big advantages there. And the displays were quite good. We had custom made displays, but in terms of cost, it was way cheaper. Like I think the Oculus was like 600. I think I forget. I don't want to mix it, but we sold for like 350 or something, and you already have a console, so you don't have to get a beefy PC. You just plug it in. So cost is like huge. I know PC gamers will like poo-poo me and be like, oh, it's penny pinching $100. I spent more of that on my GPU. It's like, I know, dude, I did too. Like, it's fine. But in the console world, like $200 is a huge deal. And so basically, if you want to get this thing out to the masses, you have to be really cost conscious. So we didn't want to introduce a new camera because we'd have to bundle it with the device and raise the price by at least another $50 or $100. So we used the existing camera tech. We used the RGB LEDs, and we did tracking that way. And so I had to, those same algorithms of like trying to hunt for pixels had to like be redone on these awkward LED shapes on the HMD. And our cameras had more resolution, but didn't matter because we wanted the tracking markers to be half the size. So basically you're still working with 4 pixels again. They always just give you 4 pixels. Like that's all you ever get, because if you get more, they make the thing smaller. So that was like,
What's
that's what I did for the PSVR.
What's the state of the art for VR now in terms of tracking? Is it the lasers and the signals?
It's a good question. I'll prefix with like, I haven't actually super duper kept up with it on like that kind of hardware level that I was at Sony, where I was really evaluating stuff. Like we had a robot arm evaluating these things like down to the sub-millimeter.
Whoa.
Like holding these objects, like we were very serious, right? Like, so when I say I haven't done it, it's like I had laser measurers and all this stuff, right? So to that level, I don't know who's the best. All the modern ones are better than what we had back in the day. So in a way, they're all kind of good enough. So then you start to think about like what trade-offs make sense. And so I think my intuition from having tried these things, I think the lighthouses are still the best in terms of quality and reliability. Just like, I think especially like the newer like Vive Pro, whatever. but no one likes setting up lighthouses just straight up. It's wires and extra stuff. And the inside out tracked systems, like the Quest cameras facing out, are good enough that I don't think most people notice the tracking difference. I can notice it because I'm like been in there too damn long. But like, you have to really fight to see the bad tracking, especially for the kind of games that people seem to be into, like Beat Saber style things where like the exact tracking is maybe not as much. And obviously the better the tracking is, the less motion sickness you will feel and all sorts of other things. But I think also by now VR has kind of filtered out a lot of people that are very motion sick, for better or for worse. So, it's a complex question. So I think better in terms of like raw accuracy, I suspect the lighthouses are still better, just kind of like if you look at the millimeter numbers. But if like, I think the inside out way makes more sense. I still like the single camera approach because inside out sucks for hands, in my opinion. Or like you need lots of cameras. Like I think the Quest 3 has more cameras aiming at your hands because you don't want to just track the head. You want to track the other pieces. And like some people that are super into VR, like track their feet and everything, right? So it just depends on what you're after. And unfortunately, there's not one perfect answer where, in a way, the lighthouse is the most complete, perfect answer because you set up the lighthouse and then you can track the hands, the feet, the head, all at high accuracy. And so for somebody who's into VR, that's the way to go. And like big screen VR, the really slim headset looks really awesome. So I think if you're like full into VR, then that's the setup you want because it gives you the most quality and the most flexibility. But if you're just dabbling and you want to play, Beat Saber to like burn off some calories, yeah, the Quest 3 is way better. And like you've got nice pass through and all this stuff. So it depends.
It depends, yeah.
As a hardcore technologist, there's one answer. As a casual VR user, is a different answer. I've worn both hats, so it's kind of.
And somewhere after the Sony PSVR, you're migrating to Media Molecule to work on Dreams, right?
Yeah, basically we did the headset and then I did like the PR tour for it, like the move, and then I was like, okay, I'm good on selling things for a while. I kind of just want to go back into developing. And then at that time, I did a lot of internal presentations showing like the new tech to Sony studios, and Media Molecules, one of the first party studios. And so at one of the internal conferences, they like chatted with me afterwards, like, hey, we really want to do something with the move. And this was like almost at the VR time. So it was like many years after. And I was like, because they put Move into Little Big Planet kind of like as a cursor for building, but not much else. But they were like, oh, we want to do something sculpting with the Move. I was like, really? This is crazy. And like, yeah, we've been working on it. We've been doing some stuff with the 3D TV. So they invited me over and I checked out their stuff and I was like, this is really cool. This is sort of what I imagine Move is meant to be doing, like things you can't do with a mouse because it's not 3D, things you can't do with a Wii because it's not precise enough. You can't do with a camera because it's not precise enough. I'm like, this is great. We should do this. So I was like, talked to Sony. I was like, hey, I want to transfer to Media Molecule and work on Dreams. Like, fine. So I transferred over and
let's maybe paint a picture what Dreams is about, like an overview.
Yeah, that's a stereotypically hard question. I mean, what Dreams ended up being was basically like a game engine on a console that lets you make games. And also, Media Molecule made a game and gave it to you as part of the game. so it's like a game about making games is how I would describe it. It's like, and the recursive nature of that is traditionally tricky to explain to people. It started out as a purely move-centric experience where you navigated dreams with moves, which were really kind of wild and zany, and you made your own dreams with moves and for other people to kind of explore. And then slowly over time, we made it more game-centric. So it's like dreams these surreal dreams that you went through became more traditional games, and they still have a dreamy aspect to it. And I don't know if you played the final game, it has like dream vibes and elements, but it became more just more close to like a traditional thing like Little Big Planet, where it's like, hey, here's some games you can make. You can make racing games, you can make action games. So it's in a way, it's kind of like Little Big Planet Unchained, where you can make anything you want instead of having to like work around the limits of what you can do with a 2D platform. You just make whatever. So yeah, so that's in a nutshell what it is. But you just look. It's hard. You Google it and you'll just see like a bunch of stuff, and you're like, but what is dreams? And it's like we never. Honestly, we never
And
got.
then you open up the trailer and it's like, "Welcome to dreams" in a dreamy voice. It's like it doesn't help. It doesn't help.
Yeah, there was an old like website back in the 90s called Zombocom. Anybody from that era would know that, you'd go to a website and it's like Zomba.com, anything at all. You can do anything at Zombocom. And it just does that for like 30 minutes. And it was like a meme of at that time. You're just like, but what is it? And it's like a little bit like that, but there is like, it's not a joke. Like you could do anything in dreams. It's sort of bizarre. Like you can do logic, you can do music, you can do game design, you can do art, you can do all these things. And like, people have used it for concept artwork for their job. They make stuff and they show it to people. Like, it's what happens when you like just double down on doing everything and then you actually do it. And it took like 10 years to develop that thing. It was bonkers, right? And so I was only working on it for about 4, right? But I think it got rewritten from the ground up like at least 4 or 5 times.
Oh, right.
Like fresh slate, not like just the game logic. Like no, like delete the directory, keep like the font importer and the texture importer. The rest, let's redo it. And like the math library or something, right? So, when people are talking about like full rewrites not working, I'm like, well, I don't know, man. Like sometimes you just gotta do a full rewrite a couple of years.
How is this
Get
possible,
that team wild.
by the way, to put this into a console who has like, well, generally much more limited hardware? And then you have this like game engine as a game already with the possibility to just like build in principle endless stuff and endless levels and everything.
Yeah, I mean it's not endless to be fair, but it's a lot for a console. I'm happy to rabbit hole in the tech of dreams for a while, but how you do it, honestly, it's like ultimately it's the people, like the right people working on the right stuff. The team at the time was like, basically a dream team, for lack of a better pun. They had like some of the best graphics people, some of the best physics people, the best network people. Like everybody was just, it was about as close probably to like an Apollo project style thing that I could imagine in terms of games, because everybody was all in on making this thing, because everybody in Media Molecule was like really passionate about user-generated content, and they're all very good developers, almost to a fault, where their passion is really to make like the best development tool and make it so good that people could use it. Like that's kind of what that becomes. But then also like big props for Sony for funding it for so damn long. I mean, like not many publishers would run that, right? And like Shuhei Yoshida was a big part of that, and Andy House and stuff. And like people really like believed in it, partially because, frankly, also Little Big Planet made a ton of money and it was very popular. So they trusted the team and everybody was very smart, but also like they believed in the vision and they were like, yeah, if we can pull this off, this would be crazy. Nice. So everyone was very, very hyped. So on a people level, you just need people. I don't know how to like try to say that. Like it sounds fluffy, right? And like, oh, it's the people. But I'm like, how do I say it? Like it really is the people. Because I've worked with people who are like, oh, that's too hard. There was no people like that at Media Molecule at the time. Like you have to have no people that ever say it's too hard. And people did get tired towards the end, fair enough. But there was a point, at least through the center of development, where people were just like, So I guess we'll need audio tools. Yeah, we'll need audio tools. Who wants to do audio tools? Like, oh, Paul. Okay, Paul will do it. Like, and it'll be like one guy. It wouldn't be like, or girl in case of Amy doing like networking. But it wasn't like, okay, here's like the Jira plan for the audio system. It was like, no, who's the best audio programmer we got? It's like, oh, okay, yeah, Paul. Paul will do that. And it would just be like, yeah, Paul will write the entire engine, right? And it was like, oh, but what about the rendering? It's like, oh yeah, Simon will do that. It was always like one person, and it was, I was the UI person. It's like, oh, we need UI for all this. It's like, yeah, Anton will do that. And it's like, okay. And then later Liam joined and helped with the DualShock. So like I did everything with the Move, and Liam did everything with the DualShock, and that was the UI team. Like, and we never had much, at least towards the end, there was more kind of project management. Hey, we really need like this, this, and this. But before then, it was just like, who's going to do the sculpting UI? Anton. Okay, this meeting's adjourned. Like, and then I would just go off and be like, hey, artists, what do you actually want to sculpt? And they're like, we want to sculpt this. And then like in the style of Michelangelo, but with Turner look. And I'm like, okay, I guess I'm going to the National Gallery and like checking those out. And like I took like reference pictures of like Turner's brush strokes and like the marble sculptures and what the texture is. And I'm like, how are we going to recreate this? And it was just like
to create this.
Oh yeah. There was very deliberate attempts, not like just as a surface filter. That was very important to us. Like we never wanted to just be like, oh, it should look like a painting. Like that was not very useful. But the way I'd say it is like digital tools, all of them, frankly, have the same fundamental problem compared to traditional media, which is that the detail has to be even everywhere. Like if you take like an Unreal Engine scene or something, or like doesn't matter, Unreal, Unity, whatever, pick an engine. Like let's say this was my room, and in the back, like everything was nice and good texture, but like my bookcase was like a placeholder 128 by 128. You look at it and be like, this is garbage. This is a garbage looking level. Somebody didn't finish it, or it didn't like preload correctly, right? But like if you look at a painting, it's like, well, if Turner doesn't want to paint the mountain in the back, like he can still do some brush strokes suggestive of a mountain, and no one goes like, oh, well, he's a lazy painter. Or like Bosch is a little different, like on your background. Like I think he just went all in on everything. Like everything is hyper detailed, which is very game-like actually. But most paintings aren't like that. Most paintings have like areas of high detail, and it's the same with any media, like even books, right? Books are not going to describe, the story in meticulous detail. Like he woke up at 6:45 and then he put on his shoes and went to the bathroom, and then this is how he went. It's like that's not a story. That's like an account of how it goes, right? And it's same thing in music. You got to leave stuff out, and it's very hard to do that in digital because it doesn't exist, right? So the main art style for Dreams was inspired by this idea of like, hey, we want to do 3D, but we need to be able to do 3D in successive level of detail. So you should be able to do low detail 3D and high detail 3D where you want it, and it not look garbage, because that's hugely important on two levels. One, for storytelling, it's actually really advantageous, but also for UGC, it's like as a single creator, I'm not going to have time to like go full Bosch on everything. So I have to have some way of, and that's like, I think why a lot of indie games are pixel art, right? Because it's like, not because they're lazy or whatever. It's like, just frankly, how much art can you do in a day? And it's like, so instead of saying, let's hit pixel art, we're like, no, let's give people tools. So that's why we investigate a lot of the traditional media and stuff. But yeah, in terms of development, everybody did that for music and forever. And so that's how you do it on a team level. You put people with high autonomy and you just let them run wild, and they have to be like very technically skilled and almost never say no. But it will also take about 10 years. So
that's wild that on this level, you were given this level of autonomy and then restarted the project for 5 times and then 10 years of funding. And honestly, the fact that Dreams shipped, it's a miracle. Like I know that like people who are incredibly skilled, but from the project management, it looks like a mess,
Yes. Yeah. I'm sure Siobhan would if you get Siobhan Reddy on, like, who was the studio head and still is the studio head, but she's like, she could talk about the project management side of things. But again, also like kudos to her for hurting all those cats for so many years and like actually getting it to the finish line. Because man, that is yeah. I wasn't there for the finishing part, but yeah, that's real.
Nice. If you were to
Yeah.
pick maybe tools or some systems from Dreams that you'd highlight from the technical standpoint, what would it be?
I mean, the tools don't have too much technical stuff behind them. I mean, we wrote our own UI system, which I guess is maybe interesting for people on a technical level if you've never done that. But like Dreams, we rewrote the UI system like it was Wednesday or whatever. It was just like, oh, let's write a new UI system. Like it was like on the low list of things that were complicated. So there was many UI systems being written, but it was like an immediate mode UI system with like interesting properties. But yeah, it's weird because when your scope is like, we're making a tool that does everything, like all sorts of things that seem big seem very small from that vantage point. And this doesn't mean because like, oh my God, we're so godly, but it's like if you set your bar really high, like I remember at some point me and Anton K were sitting there and we're like, this feels really hard because we didn't realize how hard this was. Also, this is the other key. You can't realize that Dreams is hard because if you realize it, we realized this 5 years in. At the beginning, we thought it was going to be pretty straightforward. But 5 years in, we're sitting, we're like, this seems like a hard piece of software to write. Like, why is this hard? And so like Anton K pulled up, like, just did a Google search, like, what's the hardest software to write? And it was like operating systems. And the second one was like 3D tools. And the next one was like compilers. And we're like, oh, okay. We didn't know 3D tools were hard to write. And we just like closed that web page and kept working. So there's like interesting UI tech, but it maybe less so than if we want to talk about UI tech at Adobe because that was more sophisticated. But on the engine side, it's a cool engine, and I'll highlight some things that I think are kind of different or unique from just. I actually MediaMark is like the only game company I worked at. I worked at Sony R&D and interface with game companies a lot, but my experience is like, this is how games are. And I've been told like, this is not how games are actually. So you probably have more of a window, but Alex Evans wrote like the bits of the sort of seed bits of the final rewrite. There was many rewrites, but the final rewrite was kind of interesting in that we went for like a really GPU-ish approach, I guess, which was because Alex has a GPU bias being a graphics person. And so there's just a pile of memory. How do I describe it? I don't know which end to start untangling from. Okay, so everything is a thing. So there's a class thing, and that's the only struct. It's called thing. So everything is thing. And there's 32,000 things.
Okay.
And that's just like a hard-coded number in the code. And so there's an array of 32,000 things. And the memory is sort of pre-allocated in a giant block for that many things, more or less. There's some dynamic things, but basically. And everything can have like a subclass, which is like, I'm a joint, or I'm a gadget, which is like a logic element, or I'm a sculpt. And so in effect, it's like a node of some sort, right? And then they can be connected in some ways. But you very much imagine it being like a linear array of things, and you're going to sweep all the things every frame. So you have the memory for the last game frame, and then you have the memory for the new game frame. And so it's like a const pointer to the last game. And the main loop is like you loop all the things from the last frame, and then you update them and then write them to the frame of the new thing. And then you think, oh, that's kind of interesting. And obviously there's problems with ordering and stuff like that, so you have to resolve those. But one of the interesting things about that is that creation and deletion become a lot easier to reason about than a traditional system where maybe like you're in the middle of an update loop and you like create a missile because your dude just shot a missile, and then does that missile like update this frame or the next frame, and like, or this missile exploded, and so like, is its reference still valid, or whose responsibility is it? Is it a smart pointer? Is it a weak reference? Whatever. What is it? In Dreams, very much like an immediate mode UI system, it's like you can just create stuff on that frame, and all that does is like, well, at the end of the loop, you just add the thing to the array, and it's like, okay, now it exists because like it didn't before, but like it does in the new frame, right? And if you want to delete a thing, it's like, well, it's in the old frame, and when you get to it, just skip it, and then in the next frame, it doesn't exist anymore because you didn't. So like, it's brute force management of lifetime in a way, because rather than sort of saying we're gonna poke these things one by one and try to figure out who's alive or dead, you just loop the whole thing. Say that's why I think it's like GPU-ish, because it's almost thinking in a reverse way. Like in a pixel shader, you think you're thinking from the perspective of the pixel in some sense, but you're in this larger kind of loop context. So that made some things simpler to think about.
Was this processed? Was this not processed on GPU?
No, it was on CPU, but part of the advantage of that is you can then do it in a multi-threaded way, because everything is very kind of like set up to be. And so I think it's a subtle distinction, but like in a game, you might have like a list of, like, let's say you want to select like 20 things. Like if you're making a level editor and you're like, oh, I'm going to like multi-select like five of these units or something. I'm going to move them over here. I think the intuitive way to write that is like, well, I've got my units and I'm going to make like a new array or vector or whatever you want to call it. And I'm going to say, well, here's my selected dudes. Like it's ID 5, 8, 9, 10, whatever. And I've got my selected list, and I'm going to like loop over them, and I'm going to move them. And the Dreams way is like, no, everybody has a selected flag. Like, am I selected? And it's like, you toggle that flag, and then those ones are selected, and then you just walk through everybody's like, are you selected? No. Okay, just keep moving. And then the selected ones, you move them. And so it's like inverted. Rather than looping over the selected things, you loop over everything and check if they're selected. And like everything in Dreams is like that. So if you have like an operation that's happening to something, all the operations are kind of encoded and splatted. And later, I didn't work in web at the time, but I realized that this is like kind of how SQL databases work in a way. And like we were told later, high performance databases tend to also operate in a similar way, where they batch all the commands and then they do a single sweep over the memory, because the memory reads and writes are ultimately the bottleneck. The logics tends to be pretty simple. And so it puts these like loops over all the things really primally up front. And you can't quite get away with just one loop, I think. I think you need to do some multiple passes. But it means the number of passes is like full front and center. Whereas if you do it the other way, you might easily be like, well, I've wrote this code, which is like, in my mind, I imagine like I select 5 people and then I move them, but no one's going to select 10,000 people, but then they do. And then all of a sudden you're like, oh crap, I'm looping. And so in many apps, you see this because you select 10,000 things and like it becomes slower, and it's kind of understandable. It's like, I'm doing 10,000 things, but in Dreams, it's like, no, everything's flat performance. And we wanted that for game, for the UGC side of it, because as a user, that doesn't make any damn sense. Like we wanted to deliver the fantasy of game development, right? Not like actual real game development. We have to optimize. And so if a user's like having fun and they're putting more trees, we don't want to tell them like, hey, well, you put a lot of trees, so now selecting trees. So it's like, no, it's like, it's much more fun to say you have 32,000 things and it's going to run the same, and we optimize it until it's really fast. Because the flip side is you can say, well, no, we're going to do it the other way, and then when it gets slower, we're going to optimize it. And that doesn't totally work, because it's never quite as fast as if you eat it up front. And so and this doesn't scale. So people will say, well, what happens when you do more things? And it's like, foreshadowing modeler does like 250,000 things this way, and it doesn't matter, and it's fine. But so it does actually kind of scale to any reasonable number. But the simplicity buys you a lot, and it buys the user a lot, I feel like. So that's kind of one interesting design change. I think I mentioned it on Twitter when I watched your podcast with Billy Basso, and he was like considering a similar thing. It's like, I think this works. It has some pitfalls, because like some things are hard to reason about. like especially for logic, because the logic, because there's a visual scripting language in Dreams, and it's like a logic gates programming language, and those are all things just like trees, and so they get processed in the same soup, but they have a very specific update order because you need to like flow the logic through the graph. Like if you have a visual scripting language, you know you have like this plus this. Well, you want the two arguments to evaluate before the plus clearly, so you need to do like a topological sort. But you can actually do that as you update, so it's kind of cool. You can sort of do a sort as you yeah.
Okay.
So you could do some crazy stuff, and yeah, it not everything, but like if you're very careful, there's ways to do more than one might imagine. But it's kind of a rabbit hole, and it does make the code a little bit harder to reason about. Like gameplay programmers weren't thrilled, frankly, sometimes about this.
Okay.
They were like, because they don't write shaders, right? Like I did some GPU programming, so I was like, yeah, I kind of I get it now. It's just like, yeah, this is fine.
Yeah.
But other people are like, I kind of just want my list of selected things though. And it's like, no, don't do that. It's too slow. Like, yeah, but
So you say, if first of all, you framed it nicely on Twitter back then. You said double buffering game state, which I find is a good expression. Like you have your last frame, new frame, and you operate this. But then when you have, let's say, 32,000, my first question is, if you're doing any updates, do you traverse this once during a frame, and then for each, you need to know exactly at the point where you're at this thing, you know, all the updates that you need to deliver, or you can match, like afford to just go a couple of times and first do like the first pass, and do things that need to happen first, then the second pass, and then the updates.
I think I wasn't there for shipping, so I don't know how the final system worked, frankly. But at the time we wrote it, most things can be done in single pass. Certainly most of the editor actions, because the key thing is it's also laid out in a topological way. So you're doing parents first before kids. So, and that's typically when you have ordering, that's the ordering you typically tend to want to do things with scene graphs. Like obviously you want to like update your parent matrices before your kids matrices. So if you just ensure that your things are in topological order, well, then you know by construction that by the time you get to the kids, the parents are updated. And so lo and behold, you don't have that whole like update transform hierarchy problem either, because you're up, you know, by the time you hit that point in the update. And then if you do it in parallel, you have to do it breadth first. So like you have to like put markers and be like, okay, I'm going to update like all of this level of the, so you have to be a bit careful if you're going to parallelize it, but it's doable. It's just, it's tricky, but it's doable. And then when you start to, you know, that thing I said when like, oh, when you add somebody, you just add them at the end. Well, you can't do that if it's topologically sorted. So like, exercise left for the reader. Like, how do you actually do that? But like it turns out you could like pre-count, and you know who's going to get added, where they're going to get added. You can like leave some slots, and like you could do stuff if you want to get into that.
Okay, now I understand why game programmers didn't like that. If you need to account for such things. Okay.
Yeah, so I think we pulled back a bit on that approach. So I think, I suspect, I don't know for sure, but I think there was at least 2 passes. But I think the key is that it's a bounded number of passes.
Yeah.
And that was a sort of another interesting thing that I found with like writing the UI system for Modeler later on, is like, I think there's a big difference between I'm going to do my UI or game updates in a bounded number of passes versus like an endless amount of passes where like you have dependencies that might trigger. So I think if you keep it to a bounded number, well, like it's the minimum you can do. And then if you want to do partial updates where you're like, okay, I've got these 5 things that I definitely want to update, you can put them into a separate buffer and just like do a small update on top of them. But you make that the exceptional case rather than the primary case. But one cool other side effect of this is that the whole thing's super deterministic, because it's just a pile of memory, and every frame, when we allocate the things, we allocate it into a giant pool of just, I forget what Alex called it, but it's just like basically a byte pile of just a memory chunk. Soup. I think it was called like a soup. So you had this struct called soup, and you pass the soups around. And inside the soup, there's a little mini table which tells you where's what. And so it's almost like a reflection introspection system. So like every thing, like if you're a joint, you might have different properties. So like this is the typical game problem of like, my monsters have health, but they also have like an ID of another monster they're following or something. So they have some properties that they have to track. And everybody tracks different things, and that's why you make classes, and that's why you like inherit from entity or whatever. The Dreams version is like, no, everything's a thing. A thing is an ID. It's kind of like ECS style. But we do have structs, literally structs in memory, but they're not defined, and they're defined as structs in the C++. But there's also automatic macro style code that figures out the offsets of each of these structs. And so in the soup, you can do these kind of like introspection queries, and you can know the name of each property, because you need that as an editor to be able to show to users like, here's a slider for this, and you don't want to do that stuff all manually. So there's the soup, and then there's like a descriptor of the soup, almost like a serialized version. Like serializers have to do a similar thing where there's like a bunch of data, and then you have like descriptor fields. And so you got this soup. And so what you can do for testing is you can actually, well, this is what we did. We run two of these soups in parallel. So on the dev kit, we run Dreams, and then in a separate sort of dev only thing, we run the exact same frame again on a different soup. And then we memory compare the soups, and we make sure they're identical byte for byte. So we make sure the game is deterministic. So Dreams had almost no testing in the traditional sense, like no unit testing, none of that stuff. We don't do that stuff. But what we did have is we had like a full determinism test per frame, and we had full deterministic playback. So the cool thing about Dreams is like when QA hit a bug, by which we had like, for the most development, like 1 or 2 people on QA, but they had like these superpower tools. If they hit a bug, they can hit stop. The game would stop. They have the full history of like the inputs, and the game's fully deterministic. They have the full initial state. They hit dump. It makes a screenshot, and this is the cute Alex idea, but it saves it as a PNG. So our snapshots were a PNG, but PNG has like, the file format has a comment at the end. So all of our game state would just go in the comment. So we would just send these PNGs with a screenshot. And the comment was the entire game state with the replay history. You know, QA like Dan could send it to me, and I literally open it. I can replay it. I can fast forward to exactly where he hit the bug. It's replay. Like I get the version that he used from, you know, the versioning server, replay the bug. I see it. I can see it in the break. I can see it in the debugger, like right there. And I could, so finding and tracking bugs was like way simpler than most code I've ever worked on, which is part of, I think, what enabled us to like actually rein this thing in and not it be a buggy mess, because like it's complicated, right? But like all these sorts and updates and all of that stuff. But if you can get the bug, you know, red-handed, and you've got the debugger, otherwise you have to like somehow figure out how do I attach a debugger to Dan's machine and all that, fix that stuff. So it was awesome. Like bug replayability was like top notch. And so I don't know, when people say like, oh, you gotta like unit test everything, like you could, or you can make your whole thing super deterministic, which, you know, is also really good for internet. Obviously you can like replay stuff, and you can send, anyway, you can compress things highly and all that stuff. So we had these like kind of interesting tools. I haven't seen that anywhere. I'm sure some people have done that. I think Casey might have done it for like Handmade Heroes, a similar thing, but like
there is this
like
video
thing
floating around, I think from a couple of years back, about it showcases the tools with like debugger that can go backwards in time, then forwards in time. There's like a whole gameplay stored as a session, and then the guys, I don't know, it's Tomorrow's Corporation.
Oh yeah.
And they have like, they've written their own code editor, debugger, VCS, and they like ship this stuff. Like, this is just like wow. There is some
Yeah,
skeptics in terms of like how Jonathan Lowe was skeptical that this will scale to like a
this
serious
was scale.
triple A. Like, could you store
Well,
this
I'm not gonna
session, like in a huge
the
project?
actual session of the thing.
Yeah, because it's stored like pretty much frame by frame everything, and you can just send it. It's sort of like a video session even with your local updates. So imagine you have your editor, you change a number, you save it during the development, then something crashes, and then like, whoop, here's the last 2 minutes.
Save that down.
But like, all of the data that happened.
Yeah.
But the technology was
Well,
awesome, even for like the 2D
yeah.
games, and like 85% of the games that are made probably would benefit hugely from this
And
technology.
is it public? Can you use it?
Yeah,
Or is this is a
no, this technology, no.
like not the,
The demo,
yeah.
the demo is public, but no, that's there.
Yeah, I mean, it's probably not like wise to go counter to John's opinion because he's got a ton of experience. So I'm not gonna be like, no, I think you can do it. Like, it certainly sounds like. So first off, it sounds like more memory intensive than what we did because we just replayed from the inputs, and I think, that's what Braid does. So I'm sure that's not contentious. That's perfectly fine to store. But I think in terms of storing snapshots, there is another. I mean, obviously you can do delta compression between things. So I'm sure they do something like that because if they're clever enough to write this thing, I'm sure they've exhausted the simple compression techniques that I can rattle off on in the moment. But I will say we did do a thing, which is maybe related, in the sculpting engine where we did immutable data structures, which is a sort of trendy term for like implementing things like copy on write. So the way that sculpting works is we store sparse grids for various things like evaluated. Like, well, anyways, it's not exactly how it works. But basically, imagine you have like a sculpture of something. Like in games, you often have a lot of things that are the same, and then some things that have variations. So you might have like a bunch of bricks, but each brick has like a little bit of variation, but it's almost all the same. And so one of the things we want to enable for Dreams is like, again, going back to this like fantasy of being a game dev, it's like, well, if I want to make a castle, how do I make a castle if I'm like a 4-year-old? Well, I make it out of Lego bricks. I just go, bah, 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 bah. And obviously that's not how anybody in real games makes a castle. But in Dreams, you can make a castle like that, like more or less, because we support like a whole heap of instancing, and you can sort of do that. And you might have to chunk the wall up. But how do we manage that memory? Because obviously, like if they're exactly the same, well, you just do instancing, easy peasy. But if they're not exactly the same, because you want them to be a little bit different, you might just add like a crack on one of them. And so what we do is we actually, per chunk of the thing, we can notice which chunks are different, which chunks are the same, and we data share on a chunk level, like below what the user is aware of. And on Adobe's like Substance Modeler, we do this to an extreme. So like Adobe's modeler pushes like billions of triangles. Like some of the models we have like 3 billion triangles, but we do that with sharing. So we almost like nanite meshlet kind of stuff where you can sort of like say, well, I know this bit is the same. And so I imagine you can do a similar immutable data structures hand wave on game state. So like if you're taking a game state snapshot and all I've changed is a variable from like 5 to 8, well, surely I don't need the full snapshot. I can just sort of like, instead of delta compressing the snapshot, instead do this kind of thing where you notice, well, a bunch of these memory blocks are actually identical. So I'll keep like, and you end up with this tree, and it's a complicated data structure to manage. And this is what traditionally like Haskell and all these people have, like functional programming people really love this stuff, because this is like a solution to, you return everything by value, but like, isn't that a ton of copy? It's like, well, no, we will use immutable data structures. Like, what's that? It's like, don't worry, I will explain to you. And then they get to do a lecture about immutable data structures, but they are like legit cool, because like at a high level, what's cool about it is you could just say, yeah, like logically, I just store my snapshot every frame. And it's like, isn't that slow? It's like, not really, because on the back end, we notice only the differences in the actual snapshot is. And actually, I think, I don't know, I think this is like the back end of Git as well, and all these big not to say that Git is like the paragon of happiness, but I think this does work with some caveats, and I think so. I don't know. Maybe it's doable. I'm rooting for him, I guess is what I'll say. I think that's very cool to develop that way, and if you could even do like an indie sized game, I bet there's also some things you can do that would let it scale to a AAA game by like aligning some of those things. So maybe you would say, well, maybe you don't get to do full snapshots anymore. You only get to do replays or something, or you only do store
Or
some snapshots.
every frame, like not every frame, but every now and then,
Yeah.
right? Something like that.
Yeah. So I think it's cool. And I think I like that more than tons of testing.
Oh yeah.
So that's my,
Oh yeah.
so that's,
Okay.
I think one of the things I wanted to say about Dreams was, it's hard to put your finger on it, but I think it's sort of related to this like larger war going on with programmers, sort of like, I don't know how to frame, like what's the sort of name for this social war that's happening between like the hardcore C programmers and the rest of the
You mean
world? I don't know what that
the
is, but
clean
like,
code
yeah.
kind of mentality with
Yeah, like that. Yeah, that's sort of like one of the major pitched battles. But I think it's happening on like a variety of levels. But like, I didn't appreciate at the time how much Dreams and Media Molecule at the time was like living that the hardcore C world view and shipping a real product. So I think that's maybe one of the. I'll put one for the hardcore C team here, because I think one of the feedbacks people get is like, well, you can't just like rewrite everything all the time, and like, are you gonna rewrite the CPU? And it's like, well, on it, I mean, I've written CPUs and like, whatever, like small 8-bit emulators. Like, you're not gonna write a compiler, like written compilers if you like, not major ones. You're not gonna write a language, but like. And people say, well, that doesn't work in production. It's like, well, it worked for Dreams. So for what it's worth, yeah, Dreams was long. We rewrote it like maybe too many times, but it did work. It was a roughly, kind of 50-sized person team by the end. But in the beginning, the first prototype was 2 people. And by the time I was joining, like I said, me and Liam were the UI people. There was like equally 2 or 3 audio people, 2 or 3 graphics people, 2 or 3 gameplay people, give or take when people join. This wasn't like a massive effort. What you need is people that are not afraid to go down to the lowest level of the fundamentals. And I think when people talk about like real programming versus AI slop or whatever, there's a similar flavor here where it's like, you mentioned C people are unafraid of data structures. And I think psychologically that's very important, because it sort of means at any point you can reconsider whether the problem you're stuck with is a real problem, so to speak, like an actual, like in physics, they talk about like talking from first principles, like, is this actually a speed of light kind of problem? Or is it just, just a bunch of legacy, or like just a bunch of engineering? And obviously those are huge things, right? And they take a lot of effort and things to solve, but they're not sort of, sometimes I feel like people make claims about the fundamental nature of things that are a bit overreaching. Like, you just can't do that. It's like, well, you could do that. It's like, well, no, your production schedule won't allow for it, maybe, or maybe your, experience or whatever won't allow it. But like, once you see people, like, I've seen Alex just like open a file and write a renderer like in a couple of days, right? I have seen things, it's so when people say like you can't sort of do these sorts of things, you can, and it can work on a size scale project of a game, and it's not, beyond the reach of mortals, I guess is what I would say. And so if you take that perspective, I think there's like almost a fork in the road when you're hit one of these problems. You could either say, well, this is unsolvable, and so we're going to work around it. by like adding a layer of abstraction or implementing a shim to how things used to be, like with rendering. It's like, well, it just has to be triangles, so like it's like, no, Dreams was like for a long time not triangles, it was just splatting points onto the screen. It's like, well, you can't do that because like you could. Anton K wrote an atomic compute rasterizer, like pre-nanite. He was like, actually, let's try rasterizing the triangles ourselves. Like, is that faster? And he's like, huh. Turns out, actually rasterizing triangles that are unshaded and on anti-aliased and blah, blah, blah is actually faster than the actual hardware rasterizer on the PS4. Like, you can do it faster in compute. You can do, as long as you don't do like certain kinds of testing and anti-aliasing. So it's both true that it can be done and it's faster, and also if you try to do everything, all the features, then it's slower. So like for a long time, Dreams had like an atomic CPU triangle rasterizer that was like stochastic. And so when you go to a place and they're like, you can't change the render engine, it's like, dude, you can change the rasterizer, like if you want, and it took one person, Anton K, in a few months, so it's like, it's not beyond the reach of things. So if you want to do something like Dreams, I think that is that's how all the good things get done. Now, the big luxury of Dreams, obviously, we were rewriting everything from scratch. Like, we were rethinking the whole pipeline from scratch because it was a game. So we had, in some sense, this like relaxed constraint. So like when I worked at Adobe on Modeler, you can't really do that if you're trying to make a tool that fits into other people's pipelines. Well, you do have to output triangles. Like, I can't output a list of points to Unreal because it just doesn't render them. So it's like your context matters. So I get where people say, they're like, you can't just sort of like do these wild things. So it's like, well, you can do whatever is in your scope. And sometimes what it means is like people don't feel like their scope is large enough. So within their scope, they're unable to like work around these things. But if you broaden your scope wide enough, you could.
On that note, like you also, you were working on Dreams for PlayStation, which is like limited hardware.
Yes.
So you have been constrained in this regard. And, like, I think it's much more mentality and approach, right? Like, are you risk taking? Like, are you willing to take risk?
Yeah.
Is your product manager and then director and whomever like willing to go there and risk something for this to be a bad product? And at some point when you have a business and everything is running and everything is okay and you have this like you need to watch the numbers to go steady up and stuff that. Like the you kind of get risk averse, I guess, and it's tricky to remind yourself that like to make like extremely good product that will outcompete everyone or will do something that was not done before. You need to take risks, right?
Yeah, and I mean that's big credit to Siobhan and other leadership positions, because like every level of leadership provides like an umbrella over the next one, right? It's like you have Siobhan providing head for the studio so that we have the developers can work as if there's infinite funding, and then like Shu providing the shield over worldwide studios as if the studio org is functioning well. So because they have to make these trade-offs, but like kudos to them for pushing it. And on the hardware side, it's like I think like Casey's computer enhanced course, like the paragon of this, but like there's very simple things you can do to get in touch with the machine, so to speak. Because it's like I remember one of the when Mark Cerny was designing the PS4 architecture, and he sort of talked to developers and sort of tried to balance the PS4 is a really well-made machine, in my opinion. I think a lot of developers felt that too, and it was very like it did very well. And partly because Mark balanced it very well with the CPU and GPU and the memory speed, because it's very easy to have like a lot of memory in a machine, and the consoles traditionally have less memory than like PCs. But if your GPU or CPU are underpowered, you can't actually service all of that memory at 60 frames per second or even at 30 frames per second. And so a lot of the memory just sort of sitting there. And in a way, if your game is not using all of the memory kind of every frame, it's a little bit inefficient and on some sort of high level, right? It's not always true, obviously, but you're paging things in and out and blah, blah, blah. But there's like a really simple back of the napkin we used to do for PlayStation is like, how many ALU, like arithmetic operations, can you do for every byte read out of memory? Because memory has some latencies, has some speed at which you can read, and there's some bandwidth. So like on a typical CPU, I actually don't know even on typical CPUs, but like it's like around 20 to 40 gigabits per second for like a CPU memory bus. For GPUs, it's like vastly more. It's like hundreds of gigabytes or whatever. PS4, I think it's like 180. PCs are much more. But you can do that math and you can be like, okay, for every byte that I read on the PS4, I think on the GPU is like 5 ALU ops or something. And so that gives you as a programmer a really simple mental heuristics. Like you're writing code and you're like, oh, I just did a texture read. Well, that means the next 5 ALU ops I do on that read are free, like effectively free. Like this, we're doing nothing at that point, because if you do another texture fetch, I can't do much. Now, anybody who's good at GPUs will rip me apart. This is like vastly oversimplified, but I'm just saying for somebody who's not a GPU expert, thinking in that kind of way will already get you like way closer to being performance sensitive than something else. So like when we were doing like the scene graph for Modeler at Adobe, it's like we had something slower and I was like, well, how different is this than speed of light? It's like, so people talk about speed of light coding. It's like, well, you can look at the size of your game data structure, whatever, it's a scene graph, it's an array or whatever. You're going to update most of it, probably. You're probably ticking the whole frame. Well, just take that memory divided by 20 gigabits per second. That's how many frames per second you should be going at. On some baseline level, right? You shouldn't be off by more than a factor of 10, right? And so when people look at higher level languages and you're like hundreds of times slower than that. So it's not surprising for low level people that like this feels extremely wasteful. Obviously, there's multiple passes and things are more complicated than that, but you should know what that number is rather than be like in the clouds and be like, well, I don't know how much faster it can be. Like, no, you can really pretty well establish how fast like the speed limit at which you could be going. Maybe you can't go that fast because your algorithm is complicated, but at least like take your data, divide it by the bandwidth.
Yeah.
That's probably what your bottleneck is, unless you're computing like the Mandelbrot set or something. You're super compute intensive. So you can do these things and very quickly get a sense for how fast stuff is. And so on Dreams, we would do that a lot. It's like but then you do that kind of mentality for everything. It's like, we're making music assets. Okay, well, what's the bottleneck there? The file sizes are really large. Okay, what if we make a synth? It's like, okay, we just now store the synth parameters. Oh, but it doesn't sound very good. What other synths can we make? And like very quickly, you're just like, here, we're going to rewrite the music pipeline to be granular synths compressed in this way and blah, 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 and these parameters. And it's like, cool, let's make it. Okay, let's make it. And no one pauses to think, what about OGG support and MP3? It's like, just go. It's fine. And it doesn't take so long. So just do it.
The first step is that you want to measure. You want to measure and realize whether you're in even a ballpark of the sort of theoretical solution, right? And I think that's not the common pattern. That's not the common thing people do. Like people often just write software and at some point it's deploy time, and there's no point in time in this process to take a step back and think, okay, can we do it better? Can we do it faster? Can we do it whatever? But I think
and I mean, you're right. It's probably maybe the luxury of time on, but I say the luxury of time on Dreams, but also there's a sort of bravery on the team's part, because people say, well, if my management doesn't let me, but also you could just be brave enough to say, we're doing it, and then do the other thing for a bit. You have to like, on some level, if they're like happy with your output, it's like, no, just take some time and do a thing. Like when we would hit like a problem, this is like going back on my testing rant. It's like, there was a point where Dreams got complicated enough and we're like, man, we really need some testing. And we only had one QA person, and like, just because it was not a full project. And it's like, we're having bugs, too many bugs, right? And if it was a traditional, like when I worked at Google, it'd be like, write more tests, get more test coverage. And we were just like, okay, where are our bugs coming from? Our bugs are coming from like this, and this. What would help fix those bugs? Replays. Let's write the replays. And we just that's how you approach it. You look at like what the actual problem is. Like testing is a tool. Like we had tests for the math library, because makes sense. It's like, hey, you want to make sure your matrix inverse isn't totally borked, right? But to do tests everywhere, like maybe it doesn't make sense. Look at the actual problem you're trying to solve and then craft a solution. So it's almost like don't like sleepwalk through it in a way where it's like, well, I guess we need to do some tests. It's like, no, what's the problem? The problem is this. Okay, let's write a solution. Then you just write a bespoke solution. And so I think if you maybe C trains you in a subconscious way to do that because you're running closer to the machine, so you feel like you can peak. And I think compilers train you a little bit. Like I really credit like my compilers university course, even though it's not like real compilers, but like even just going through the process of writing a toy compiler, it demystifies languages in some sense. It makes it less like, oh, these are just magical incantations. Like, no, under the hood, it's like pushing a pointer somewhere and making you some stack. Okay. And yeah, it gets much more complicated, but on some level, like, it's not crazy. And so you can do these things. And so having that feeling of you can do these things, I think is really, really useful and important. It's like, that's why I urge people to like develop that. And I worry with AI a little bit that we may lose some of that because I think AI, I feel like, I don't know, like the closest analogy I have is like, you come in like a city and it's like covered in trash and you like move in, you're like, wow, this city is full of trash. And everyone's like, yeah, but you just live with it. Like, here's my trash shovel. It's really large. And like, it was like, well, why don't you just like clean the place up? It's like, well, that'd be a lot of work. And like, it's been this way for a long time. And like, some of the houses are built on trash. So if we remove the trash, like people won't have a job or a house. So like, you just got to live with the trash and look, here's this new trash shovel. And then someone comes in, it's like, I've built an AI trash excavator and it's like shovels trash at like an amazing rate. And everyone's like, brilliant. This is exactly what we needed. And you're just like, but can't we just fix the trash? Like, isn't that a thing? And I get it because like in a way nature is sort of like this. Like you kind of just build on things and you don't like rewrite, but like also there's wildfires and they kind of rewrite the forest in a way. so
that
so that's how
analogy,
I kind of
analogy just like shoot off. Nice.
yeah. So that's how I sort of think about these things. Like sometimes we always try to make software like the development tools on Dreams and the user tools both had the mentality of like when faced with a hard problem, don't try to just make a tool that makes the current thing faster, like by fixing the UX or the performance. Rethink the problem. Can you make it go away at the fundamental level, right? And if you can't make it go away, can you make most of it go away? Or at least like lower the exponential rather than just being like, oh, this thing is growing linearly or logarithmically. Let's like optimize it so it's not, or let's like do something. It's like, can we just bend the line, right? And I think on that front, the performance people all agree that, O of N, you want to try to bend that down before you get into SIMD, right? Like no contention there. So it's like try to do that across tools, across your development process. I think that's the kind of the trick is like, yeah, that's the best I can say. It's like rather than just reaching for a big shovel and then do the big shovel on top, and then you'll have like excavators in a beautiful, clean city, and that will be even more beautiful and it'll be great.
I want to talk to you about your time at Google because this would be super interesting to first talk about what you've done there and then to contrast the style of development in the Google as being like a big tech member and then the sort of like triple A mindset of game development, which is probably in some senses similar, but some senses probably vastly apart. So what have you done at Google? What have you worked on?
Well, I went to Google because they spun up like a VR effort at the time. And so they were, I think, unannounced. I think they've since had another unannounced. I'm not sure. I haven't been following, but they had a VR effort. And so they invited me to work on like a VR bring up since I had experience with PSVR and stuff. And so I joined there to do VR, and I was doing kind of some prototyping and rendering stuff for VR. So I did a lot of SDF stuff in there and like different renderers and things like that. But that all like didn't actually come to fruition because they abandoned the VR stuff as the hype started kind of dwindling down. So the group I was in was also like a researchy group, and a lot of them were doing machine learning at the time, like before, like deep learning stuff before the big LLM craze and image recognition and stuff like that. And I had some background in that too. So I ended up as the graphics person at Google. And it was kind of an interesting experience because like, I came out of Media Molecule with like real graphics people, so to speak. I'm not sort of a graphics person by game dev standards, but by Google standards, I'm a graphics person because there's just not that much. There are great. I'm not trying to like, I don't want to like poo-poo on it. There's lots of smart graphics people at Google, but generally speaking, obviously people are much more in like the web and server and backend stuff. So like the typical person in games knows much more about graphics than like the typical person in Google. So anyway, I was good enough to do graphics work for the ML group. So I worked on like the face recognition stuff for the Google Pixel phones by simulating training data for AI. So I used my camera tracking background because like I understand cameras fairly well, and I can model the camera lens parameters and the noise parameters. And so it turns out, this is now pretty well known, but like if you simulate the camera well, the training data is more representative of like the real world. And so when you want to do like machine learning, you want to supplement your training data with synthetic data just for quantity. At least I don't know what the latest state of the art is, but at the time that was very useful. So I generated synthetic data for them for cameras, and that went into the Pixel unlock. But in terms of like the actual dev style, it's very different. The VR group was probably the closest to games because they were real time, and you have to like many people at Google are just on like a Chromebook or something, or like a laptop equivalent, because they're essentially SSHing into like a giant server farm and running their algorithms, which have no visual output. They're like some sort of backend sweep of this and that, put it into here and that. And like game dev, like everything you do usually ends up as a pixel on the screen somewhere, like more or less, right? So that's one big difference. And so to not have like a local machine that's representative of, so it was just a weird experience for me because I'm like, every machine's like really underpowered. And so I was doing rendering of this synthetic data. And this was kind of like maybe an interesting contrast point. It's like I was rendering these images, right? And I was ray tracing them. So I wrote like a toy ray tracer to do this data. And I was running them locally because I had my, when I joined for VR. So they gave me a beefy rig. So I had like a pretty beefy development rig, and I was rendering these images, and, I was rendering them at game rates, 60 frames per second, because it's a ray tracer written on the GPU. And it was like, fine. And their pipeline that they were using was using like Blender in the cloud or some version thereof or something. I don't remember what they were actually using.
Okay.
But like, I don't want to incriminate anyone, but like some version of like some kind of thing up in some cloud. So they would submit some data to be rendered. It would like spin up a server instance somewhere. It would then like render it either on CPU or GPU or something, right? Some version thereof. And then you would get back that image. It would store it in some thing. And I just wrote it in GLSL, right? Like Inigo style, like pulled from his shader toy and others, and just like rendered stuff. And they were like, how is this possible? Like, I'm not trying to like demean anybody, but there was like a process shock of sorts where they're like, so when I would deliver them these data sets, they were like, we need 100,000 images. I'm like, cool. That'll be just like 10 minutes, whatever. Just, or found like, but don't you want it in the cloud? I'm like, why? Like, well, then it could be faster. I'm like, but will it though? Like, did you run the numbers? They're like, no, but surely it will be. And I'm like, but did you run the numbers? Because it takes time to send the stuff up. It takes time to spin up an instance. It takes time to blah, 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 blah. And they're like, well, yeah, but once it's on there. And I'm like, well, once it's on there, like how many GPUs do you have in the cloud? Are those being shared for ML? Like, did you actually run that? No one ever ran the numbers. And so in every meeting, people would be like, when are you going to put it on the cloud? I'm like, when somebody proves to me that it's worth it to put it on the cloud, I'll put it on the cloud. Until then, just send me an email and I'll send you back 100,000 images in 30 minutes. And that was like a big point of contention because they were like, this is very un-Google because for one, I'm like a point of failure, right? Like if I leave, then what? Like, and I'm like, well, if I leave, you're screwed anyway because none of you know how to do this. So like no one's gonna maintain this. Like, yeah, but then we could like, and you know, I wasn't like actively hostile about it, but I was just like, I didn't understand the idea because a medium molecule, it was like I said, it was one person per thing. So it's like if anyone's left, obviously it's terrible. Like obviously that's a problem. But Google is such a huge company and they're so geared around this idea that if someone leaves, it should be kind of a non-event, or because they might just want to move to a different team.
Yeah.
And I always felt like it's like asking like, what happens if one of the Beatles leaves? Like, how do you keep the Beatles going? It's like, you don't. It's just like it breaks. And I just like assumed that that's how things are because that's how game teams are, especially small game teams. It's like, no, people are really, really important. And Google, for better or for worse, tries to make people much, much less important. I never liked that because I was like, I don't know. It wasn't even like an ego thing of like, I want to be valuable and I want job security. It was more just like, I just don't like, I like automating things to make my job faster. I don't have any problem with like automating myself away, but like, I don't want to spend time doing it if there's no point. Like, I just don't want to waste my time. And so I was like, you just need some images. Let's make some images. Like, what's the problem?
You gotta appreciate like 20 minutes ago we said like nobody really measures this stuff. And then it's like you should put it on the cloud. It should be faster because it's cloud. It's like bigger. It's like okay. Like nice.
So in the end, right before I left, I did put it on the cloud because they really asked me to, and they already said I'm leaving and stuff. And it wasn't obviously faster. So, you know, I was sort of vindicated in a way. And I, you know, but it was on the cloud and they were sort of happy. That was like my parting gift. I don't know if anyone actually used it, but I converted like an Inigo style Ray Marcher, but into like NumPy. So it could run on CUDA. So like imagine having like a pixel shader, but in NumPy.
Oh, wow. Okay.
Right? Because like that's how you do big arrays on big data, and then it can be like on a TPU or a CPU, or it could be in whatever. And so I also wrote a little compiler that took like GLSL like stuff, like simple expressions. I make a little compile tree, and then I did like in ML you do backpropagation to do like gradients and training. So they wanted like a differentiable renderer thing. So I was like, oh, well, SDFs are really nice for this. Like this was before the whole ML craze, but since I was coming hot off of SDFs on Dreams, they're like, we want a differentiable renderer. And I was like, well, in SDF ray marchers, you're differentiating them all the time because you need normals, right? Because you're just like, I don't know if you've ever done a ray marcher, but you basically like you're ray tracing these signed distance functions, and they're just math functions, so like circles, like length, position minus radius or something. So they're really simple math functions in some sense. And these fields, like they define the surface. I don't know, no easy, quick way of doing it, but you can go to Inigo's website, hashtag like ray marching. But the derivative of these fields happens to be the normal, because it's like the derivative is the gradient. In math terms, the gradient points in the direction of most change, right? And so in these fields, the direction that points towards the most change is away from the field. That's just like the property of these functions, which is great. So to get the normal, you just take the derivative of the field. So I was like, I do derivatives all the time. And then you do them, and then they're like, well, we need better derivatives. And I was like, how do you do it? And they're like, we do backpropagation. I'm like, what's that? I don't know what that is. And they're like, it's actually just autodiff, but you know, whatever. So I looked up autodiff, learned that stuff. And then I was like, okay, why don't we take shader toys style things and we'll like make an expression tree, write a little like compiler thing, and then spit out like a autodiffed. Autodiff is like this way of doing automatic differentiation. It's like a way of doing derivatives in an analytic way, but you know, look it up if you're curious, Matthew. You could do this. You could take the shaders and you can dump this thing out, and you get perfect derivatives, aka perfect normals, and it looks very beautiful. We tried that on Dreams to do perfect normals for a little bit. Um, so you could do that, and then you can then convert it to NumPy, and then it can run on the cloud and give you derivatives and all this beautiful stuff. It's
You're
kind of cute.
one of not many people that have as both background in terms of ML, the classical ML, but also graphics, and you can do like the swap from one to another
Swap.
because it's like a
Yeah,
lot of the things are shared or just similar, but they have vastly different nomenclature. Like the words are different,
yeah,
but like core concepts are very much similar. So
yeah. It's the same thing. It's like when I started doing it, I talked to the ML people. I'm like, how do you do this? And they're like, well, we use TensorFlow. I'm like, what's inside TensorFlow? They're like, well, there's like back propagation-y stuff. I'm like, what's back propagation? Like, and then you quickly narrow down the pool to find people who actually know what they're talking about, right? Even within, because there's a lot of people that just
yeah.
TensorFlow, man, or like they just do whatever, and then there's the next level of people who know how to do the NumPy, and then there's like, what's NumPy? Oh, actually, that's CLAPACK under the hood. It's like, oh, I use CLAPACK. It's actually a C library. Like, no, it's actually like NumPy is like eigen wrapped C++, and eigen is like CLAPACK wrapped. So I was like, just go to CLAPACK. Let's just cut to the chase, because that's a bunch of really carefully written C that's been around since the 80s. And it's like, that's the good stuff. This is actual like super duper kernel tested thing. It's like eigen is just like a template wrapper over that. Whatever. I don't want to offend people. There's more stuff in there. And then like NumPy is like a wrapper over eigen, I think. And I'm like, okay, these are just syntactic sugars, and TensorFlow is like a wrapper on top of NumPy. But I'm like, if we want to understand this, let's like go to the bottom, and then you just and so I asked Google when I was switching to the group. I'm like, can I just learn about ML for like 6 months? And they're like, sure. So I wrote my own like back prop thing to sort of specify my own network. And I learned about like how the actual training works. So I actually don't know a ton about like ML architecture, but I know a decent amount about like the low level stuff. And then it's like, now you can talk to people and then be like, hey, did you know like you can do this? And they're like, oh, you can? I'm like, yeah, you just add this thing, right? And instead of like piling more nodes in TensorFlow, you like just make a new node or whatever, you make a thing. So I think it's, again, like you just dig. You got to dig at least one level below the abstraction you're working on, I think, is like the truism. I think you got to do that. If you don't do that, then you're like not cool.
Why did you leave Google?
I wasn't. I mean, I got invited to Adobe, but to work on Modeler specifically. Like I don't think I would have just sort of flat walked to Adobe, but Modeler was this like cool VR tool. It was like, and they wanted, the history of it was you know there was a thing called Medium that Oculus developed, the team inside Oculus, led by Lydia Choi and Brian Sharp, and we met with those people when we were doing Dreams, like at events and stuff, because they were doing VR modeling and sculpting and SDF kind of stuff, and we were doing it in Dreams, and there was different approaches, but they were doing cool stuff, we were doing cool stuff, so we would just like chat over beers. And that didn't really go far in Facebook ultimately, and Facebook graciously sold them off to Adobe. Not exactly Adobe, because Adobe acquired Substance, which was like this tool to make textures and so forth. And the leader of Substance, Seb, was very into cool 3D things. And so he acquired Medium and gave Lydia a headcount. And Lydia was like, hey, you're not a mini molecule anymore. Like, you want to do that again? And I was like, yeah, that sounds cool. Because like Google's asking me to put things on the cloud and I don't want to. Like, I don't understand. So I mostly came over for that. Like Google, but it's like, it's really hard to, like, one thing I learned about at Google, like, was like, you kind of, if you want to figure out what things converge, like what the projects converge to ultimately, you can follow the money in a company. And so in Google, things converge towards like ads or search, and search in some way converges to ads, because like that's how Google ultimately makes money. And so when you look at like why Google canceled this or that, it usually is about like, well, it doesn't actually dovetail into ads or search, and search kind of dovetails to ads. And so like, why is AI like good at Google? It's like, well, it's like it hurts their search, or like it sort of competes with their search, so they kind of have to do it. But everything else, you can kind of predict the outcome by figuring out, does your thing actually align with ads or search? And so it ultimately, all the ML stuff that we were working on had to like, in some indirect way, align to that. And I was like, I'm not really like that excited about making ads better. But interesting that also I think applies to Dreams. Like Dreams started out as like a much more purist art tool and ultimately morphed into more of a game thing. It's like, well, why? Well, it's because Sony sold games. Like Sony's feedback for Dreams was always like, you guys are amazing. You're doing crazy stuff right now, but can you please make a game? And that was like the feedback for years. And it was not wrong, right? I'm actually not trying to like throw shade on either of them, but it's like, no, that's the core business. And the core business of Sony is games. And so things should be gamish, and it's the core business of, And so my feeling was like, okay, well, Adobe's core business is tools, right? And so let's like, surely if we're going to do a tool like Dreams and Medium, like out of all the companies that could actually fund the thing, this seems like the place that could fund it, right? Because who else will fund it? Microsoft won't fund it. Like Microsoft had this thing called Maquette. They discontinued it. Joshua, who's the designer on Maquette, was also a designer on Modeler with me. And so all of the people that were like doing stuff, Oculus ditched Medium, Microsoft ditched Maquette, Sony didn't like ditch Dreams, but effectively the tools side of Dreams was never really gonna like super flourish inside Sony because it's supposed to be games centric. So fair enough. So all of the like Modeler is sort of this team of ex 3D tool developers under the one company that still has something like a tools funnel, right? Like because Photoshop is sort of the business, right? So that's mainly why I went in for that ride.
Do you work?
Just the dev process at Google is like so slow, man. Like you make a change, and then it's like you got to get reviewed. And I was like, reviewed? What are you talking about? We did no code review in Media Molecule. There was not a thing. Like people are like, you can't
not
just
at all.
No. Like we did like I think there was like a soft policy that the first person, like when you first join, the first 4 commits get reviewed by like a director, and then that's it. Like that was, and it was just to make sure like you understood. It wasn't because like and then Google's like, you need to get like a certification of like C++ readability, and then blah blah blah. And people are just, again, it's like people are like, you can't develop things if you don't do this. I'm like, dude, you super can. And then testing and continuous integration, like again, the continuous integration things, like you have to wait for your like commit to pass test to blah blah blah. Dude, we didn't do any of that on Dreams. You just slam it into main, like, and then the build bot would just make a build every hour, like from whatever was at main at the top of the hour, because you don't need a build for everything, like no need. And you had a button called like build now. So if you slam a commit in, you hit build now, and then the artist will get a build in like 3 minutes or something. Like that's the other thing. Dreams built in like 3 minutes on a laptop, which is maybe not impressive for like somebody who's like in Jai world or something, but like it was like 250K lines or something of code, and it was like written to build fast. So there was like a build thing, and you just make a build. And I was like, we did not have problems. That was not the problem we faced, right? Like, sure, yes, it was like merge conflicts, and I lost like a bit of code once in a while, but dude, given the other problems, this was so minor that like it won us so much more time being able to just like push the trunk than. So anyway, so like coming into Google, like I was like, can I just not do this? Because I know it's fine. And they're like, no, you can't do this. I'm like, dude, you guys are coding at like, this whole 10x engineer thing. I was like, 10x engineers, I'm not gonna get into like whether they exist or not, but like, dude, you are 0.1x on productivity just by virtue of your build process. So like you could all be 10x engineers at least just by like not doing this, just slam it into trunk. And they're like, no, this is too crazy.
Did you get away? Did you get away with these checks when you were doing this locally on your BV stuff?
Well, locally, I just didn't check anything in.
Exactly.
Just like,
so you were
fine.
You were
so that's what I did. I just did that forever because I was like, my output is the data. Like, they're like, can you check your code? I'm like, sure. Where can I check it in? They're like, well, you got to pass review. I'm like, well, there's like 10,000 lines. And they're like, how'd you write 10,000 lines in like 3 weeks? I'm like, you can write a lot of lines if no one's like complaining about how many lines you're writing, man. It's like, you grab this, you put that, and then they're like, okay, so who's gonna review it? And I'm like, why do you need to review it? Like, you're making images. It just didn't compute. And so ultimately I just sort of ran on this. I'm like, well, my output is images, right? And they're like, well, your output's, I think they wanted my output to be code. And so there's a branch in Google called experimental where you can check anything in, it's unreviewed because it's not part of production. So I just checked it into there. And they were like,
Nice.
that was where my code was checked in. And there was no, and I just checked it in like weekly. Like I didn't actually do commits, like, cause
Nice.
whatever, you just move forward. That's the other thing. You just move forward. Like people, I don't know. Their whole rewrite thing is like I learned a bunch from Alex. That was probably like one of the main things. He was like, look, I've written this before, and most people are like, I don't want to write it again. But he was like, I don't really want to write it again, but I'll probably write it better this time, and it's good practice. And at first that's slow, but you can get very good at that. So you if you want to write like stud vector, like there are people, as crazy as it sounds, who can make a perfect stud vector implementation. Like Alex is the closest I've seen to like coding like you see an LLM code, where it just kind of comes out. Like if you've seen like cursor code, so you could sit Alex down and like one time we're sitting at my desk and he was like, I want to use MIDI to control like this thing in Dreams. And I was like, oh, so you want to get like a MIDI library? He's like, no, we're not going to do a MIDI library. I'm like, what are we going to do? He's like, well, MIDI protocol is like pretty simple. Let's just hook up a MIDI device. I'm like, how do you hook up a MIDI device? Like, I have no idea. He's like, we just open a socket. I'm like, what do you mean? So he like opens us like in code. He's just like open socket. And I think he's like, I think the path is like /MIDI or whatever, like open COM port. And it's like, okay, and the characters, I think are like C, D, and 4. And he just like bum, 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 bum. And he just like wrote it. And it was like 300 lines. And it was like at lunch, and like, and then plug in the device and then like it read the MIDI, and it's like, when you see someone do that, you're like, well, you could say, oh my God, this is like godly, but like, no, you could do this with enough practice, right? It's like, if you practice it, you'll do it. And if you don't practice it, you'll say this is impossible. And so when you have someone like that, it's like, you're not going to tell somebody who can write that much code off the top of their head that they have to like spend the next 2 days code reviewing it and putting it through. Like that's masochism, right? So
but
like,
is it such a waste for the company as well, right? Is it?
it is, I think, but I've come to think that the way they used to think, maybe they think of this less now after the layoffs or something. But I think their feeling was like, look, we have so many people. There's so many people wanting to work for Google. They have so many people who are like coming in and out. They need to optimize for people coming and going. And so their optimization with testing and infrastructure is like, they have assumed people are going to come and go. They have assumed they have an endless pool of talent. So talent is not, like, in some sense, talent is not that important. I guess talent being like the people. And so I think that their feeling is almost like, if a person comes in, there's a lot of value in, if they just make like 10 lines of change, but those 10 lines are like rock solid, that's really useful for them. Versus if a person comes in and they break 300 lines, that's really bad. And so I think, for better or for worse, that's the way I understand that coding strategy in a way. And so I think of testing as kind of like rejection sampling. I don't know, even like random generation code. Like if you like to say, you want to like random sample a circle or something, right?
Yeah.
Like you can be smart and like invert and like warp your random distribution to make exactly the circle samples.
Yeah.
Or you can just generate samples in a square and then reject the ones that are inside the circle. And that one's actually easier to write because it's easier to test whether you're in the circle than it is to come up with the clever function to like sample only in the circle. And then if you have a triangle, then you're like, oh, I got to come up with another way of. And so mentally, I think of the Google testing framework as like rejection sampling. So code programmers can just throw code at the wall, and the code that's wrong will be rejection sampled out of the framework in a way. And so I actually think of AI code very similarly as well. Like when you have a brute force onslaught that can generate code really rapidly, effectively for cheap, well, it's just as easy to write a rejection function, and it's sometimes easier in some sense. So I think of that's almost the opposite approach. Like you write the test cases, and that's how I think of test-driven development stuff. It's like you you choose to write the rejection function as opposed to writing some minimally compressed version, because the computer doesn't care which one you choose. Humans care maybe because of readability, and I think humans care because of like beauty and elegance, that like in some sense one is more pure than the other, but like from a computer standpoint, I don't care. And I think that's AI is just throwing stuff, and it's just like, let me see if this compiles. Oh, linter errors. Let me rewrite it. Linter errors. Okay, let me try this. It's like cool. And like as a programmer, I don't want to be a test writer. Like I guess that's not why I got into programming at the core level. Like I like making the beauty of the code. And so
Why did you get into programming?
I just think it's really like satisfying to write some stuff and then pixels show up on the screen and lights dance around. I think there's some sort of very primal, like I've thought about it and I can't come up with any better explanation. And I think partly that is why I didn't enjoy Google as much, because I think, you know, you write some code, you kick it off to a server, it does some compile, it deploys. It's like 30-minute lag time between when I do something and something actually happens anywhere. And usually it happens in a server log somewhere where I pull it down. It said 98% instead of 97%. And I'm like, dude, this is really unrewarding. Just sort of visually, you know, I think that's the best I can put it. It's like, kudos to people who are in, like, I'm not like throwing shade. Like I think solving interesting programmer puzzles is cool. Like I enjoy it to some degree, but I think like on some really dumb human meat sack thing, like I get happier from seeing things move on the screen and I'm like, oh, that's cool. That was cool. That was worth it, like on some internal level. So, but if someone doesn't have that and they're like, oh, I really loved it when the ML loss function went from 3 to 2, that made my day. Like, cool, man.
The optimization can be a game that you can get a lot
Yeah.
of dopamine from. So
yeah, I couldn't figure it out. If you know how to do the dopamine, I'd love to hear some tips. I couldn't get the dopamine flowing, I guess is a good way to put it. Yeah.
Tell me a little bit about Substance 3D modeler at Adobe. How was your involvement in this project? What did you do? And maybe some cool things about, if you can share.
Yeah. So the pitch for that project was, you know, they had the Oculus Medium code base, which is a sculpting VR tool, and Substance acquired it, and their hope was to add like a modeling tool to their Substance suite. And so the two kind of key things I needed to do is make it work on desktop as well as VR, and then also make it work for assembling scenes, not just sort of individual objects, because like Substance Modeler was, Medium was very much like single sculpt focused. So you sculpt characters or props, and they wanted to do full scenes. And so my experience on Dreams doing like large scenes and environments was important for that. And then also being able to run it on both like 6 degree of freedom move style controllers and also like other devices, like Dreams ran on a gamepad. So there's this like, I guess, somewhat unique problem of making the same UI work on multiple input devices that are like very different, because one is very spatial. And so to that end, like the key things I wrote, like for the UI part, I wrote a UI toolkit that ran both in VR and on desktop, because we just needed one. We tried, well, we didn't need one, but like the other option was like you use Qt or something, or like Electron was being used at Adobe a lot, but I was like, oh, these are so gross. But in VR, the only way you can use those is you render them to a flat quad, and it just looks crappy, right? It just looks crappy. There's no other way to put it. It's functional, but it's flat. Like, why would you do that in VR? It's gross. And also VR requires a lot of animations to again look good. Again, you can do a crappy version this way, but if you want to, and you know, I'm vindicated by like Apple's VR headset, even though it hasn't sort of blown out of the water, but like Apple doing VR is like, look, their buttons are like good looking and their UX is flowing and moving and all these things. It's like, that's the bar, right? So that was my justification for writing a UI toolkit. And also, like, I think the other ones are gross. So I wrote one, and so it's like kind of like an I am GUI thing. Omar, who wrote like DRM GUI, used to work in Media Molecule. I don't know if that was like well known, but so I worked with Omar a little bit there, and so Media Molecule kind of bankrolled the first DRM GUI and open sourced it. So like I had exposure to that world, and so I was like, this is one of those things that isn't beyond the reach of mortals. So we did that, and it's very similar to the thing I wrote to, like this system Clay that was making the rounds on YouTube. The guy wrote it in C. Very similar.
Nick Barker.
Okay, cool. Yeah, I had a quick chat with him on Twitter actually, but I didn't. I'm really bad with names. I apologize. Did you talk to him? Seems like he'd be a.
Yes, if everything goes okay, this Saturday will be the
There we
episode.
go. This is perfect dovetailing because.
Yeah.
So we I mean, it's Clay is almost to a T what we wrote, or like what I ended up writing. There's some differences, but effectively, like the realization is the same. Where I won't. He could talk about it. He'll be he'll be more interesting. But basically, like if you take a sensible subset of, Flexbox, which is what Figma does too. Like the Figma auto layout is just like, look, most of the HTML CSS stuff is like overkill. Let's just stick to the basics and have like rows and columns. If you just do that, barring a few other constraints, you can do it in a few passes to do the layout, and you can do it fully dynamically, and you can do it in media mode, and you can cache it and all this beautiful stuff. So anybody who is like, oh, in media mode, like doesn't work in production, it's like, well, it worked fine in Modeler. Like you can look at the UI. It's not the most complex UI, but like it renders fast and takes like the full layout is sub-millisecond to do a full 10K elements or something. So, and this is like full layout. IM GUI, DRM GUI does like a simplified version of layout because it doesn't, it does it as it goes. So it can't do like things like, it doesn't know how big something is going to be before it completes like a region. So it can't do like automatic styling. So it usually forces the programmer to do some automatic styling. Actually, it might have some things for it now that I'm not aware of. Maybe he's able to do it more, but it's not designed for that. Like Omar never made it for like production, and he'll be the first to say like for production you want more animation and things like that. It's made for debug UI, but you can actually, so people say, well, DRM GUI, like you can't use it for production because it doesn't do this, and in production you must be able to specify dynamics. Like, dude, it's fine, you can do that. So basically all we do is we defer the layout till the end, and you still keep the immediate mode interface, and you still keep the whole, like you can add things, remove things, but then the back end figures it out. So there's like a tree diff that happens on the back end that like looks at the prior frame, looks at the current frame, figures out what appeared. I guess that's kind of like how React does the DOM abstraction, but like, I don't know, man. So anyway, you wrote that thing, and so that way you can work in 3D, and we can make, like, we actually do some Z stacking too. So I wrote that bit for them, and we use that for the UI system. And then on the scene assembly stuff, we needed to upgrade the scene graph because the modeler scene graph or the medium scene graph was only really designed for a couple of hundred things. We wanted to do thousands of things like Dreams. So I did like the same back of the napkin stuff that we did on Dreams, and it worked out. Like on a typical PC, you can do like 200,000 things at like 1 millisecond, which was my budget. So like if your scene graph is less than 200,000 things, a millisecond sort of brute force should implement most operations you care about. So, and I think like Max Liani, I think on Twitter was doing like a render, and he sort of also showed similar things. So again, it's like a weird bifurcated world where we live in, where like hundreds of things seem like impossible, but if you sort of write it. So yes. So in that structure is really also similar. I just allocate a flat array. It's even easier on Windows. On Windows, you can do this really dumb trick that I learned from like our machinery guys that imploded. But you can like virtually allocate just a gigabyte of memory, and Windows will just page it in. And so you don't even need to like think about too much memory management. You're just like, oh, I'm gonna allocate 1 million nodes, and so our budget is like 1 million, and we just add to the array. Like, and if someone hits the end, like you're gonna hit the rendering limit before you hit the scene graph limit. Um, Realistically, right? And so people are like, well, how do you like reallocate? So I didn't even write like on Dreams. I had like a slab allocator to sort of like ensure that the pointers stay consistent. Here, I just allocate like 60 gigabytes or something for all the arrays, and Windows is just like Windows pages it in as the user uses it. Um, so you could do. I think we rewrote some parts of it, but Windows doesn't care. That's not real memory anyway. It's just a ton of address space. Um, I don't know. Maybe that's mean, but so we do that, and then it's all just one flat thing. Everything is a node, similar to how everything in Dreams is a thing. And then we have some cool stuff where you can do kind of instancing on a per object basis, and you can do instancing on the hierarchies, so you can sort of like have castles on castles, and yeah. So that was like a more sophisticated layout version. And then when we did that, it was cool because it forced everything to kind of like render faster as well, because there was like it was interesting. Rendering in VR is really challenging, right? Because you're rendering really 90 frames per second, and you're sort of obviously very resource constrained. And being on Oculus, especially like coming from the older hardware times, like Medium's code base was very careful about how much it rendered. And so like that's why there was a sort of built-in assumption in the Medium code base that we're not going to render more than like 100 objects or something, or like 200. And so these layers, as we called them, they were like 3D voxel things, and each one you can kind of model on it and duplicate it. And in Dreams, we just duplicated stuff like free cheese, like it was. But to support that, you need all this backend stuff like the immutable data structures or some kind of memory deduplication. And until you need it, you don't write it, is the best way I can put it. Like Medium had some really great engineers, but there was a sort of like assumption where like, well, we're not going to do more than 200. And so part of like my soft job was like to come in and be like, no, we're going to do like 100,000. And they're like, what? That doesn't work. And I was like, well, I'll fix the scene graph. So I fixed the scene graph, and now the scene graph like magically handled hundreds of thousands. And then everyone kind of got like inspired, and they're like, oh, let's fix this. And all of a sudden, like David rewrote like most of Nanite, not most, but like the bits of Nanite that were needed, right? And Dreams had like pre-Nanite kinds of things too. And so all of a sudden we were rendering like 1 billion triangles in VR. And that's like, if someone set out and said, how many can you render in VR? It's like, well, I don't know, maybe 2 million or something. But like, no, if you sort of try, it's the same people, just the mindset change of like, let's just do it. And once people start cranking on it. So there's some cool tech inside there to render all that quickly. So I guess if people like as a reference point, Modeler does like on the order of 1 to 10,000 UI nodes in immediate mode in under a millisecond in VR and in desktop, no problem. And it does hundreds of thousands, like 200,000-ish instances in a scene graph rendered 2 billion triangles in VR. These things are possible. These are not mythical, unachievable things. The team size is, on the order of 10 people or less. It's doable for what it's worth, forgetting like the product reasons or the, anything else on a technical level. These things are possible. They're not mythical. And
have you been pushed on this from the product side, or like, why are you spending time on this, or sort of like, how did it happen?
Luckily, not really, because Seb, who like was the head of Substance at the time, he's sort of left since then, but he was very, I mean, again, yeah, maybe this is again a lucky term, but he was very sort of a patron of the arts, so to speak. So he was like very excited about this sort of stuff. So if you tell him, hey, we're gonna like make this next gen thing that's gonna push tons of triangles and be in VR and allow all these things and sculpting, he's like, great, like sounds awesome. So I don't know if it's a
Okay.
good product decision. This maybe not a product podcast, but
Yeah.
I think no, I think it's a valid point. I think if you get pushback, it's hard, and it's not it's not always wrong to get pushback either. I think is the subtle point. But like, I think within the realm of what you're asked to do, I think doing a good job inspires other people to do a good job. It's like the Japan trash policy, right? Like if Japan is clean, like going back to the trash analogy, like Japan has almost no garbage cans, like which is kind of
Yeah.
interesting. And people are like, where do I put my garbage? If you come, it's like, take it home. Like, and then very quickly you realize, wow, it's very clean. And it's like, you would imagine if there's no trash cans, it would just be really dirty. But actually, if everyone like is inspired to keep it clean, it stays clean. And so like it stays clean because it's clean. So there's a sort of momentum. And I think if your software stays performant because it's performant, there's a sort of virtuous cycle versus if your software is accepted to be slow or accepted to be bloated or accepted to have a slow compile time, it will remain that way. You know, I remember this on Dreams. I was talking to Alex and we're like, are we going to run at 30 or 60? And I was like, I don't know. Can we run at 60 or 30, Alex? He's like, it doesn't matter. You just choose. And I was like, this is the most Zen answer I heard. It's like, it wasn't like, here's what we can do in 60. It's like, no, you just decide. And then you make that one happen. And it will be the truth. You know, it's like if you run at 60, you will stay running 60. If you run at 30, you will stay running 30. You will not magically optimize to 60 later without a
Yes.
heroic effort. And so I think it's like you just choose. Do you choose to be
Do
low
you choose
dependency?
performance?
Yeah, you must
Choose
choose if you
performance.
choose performance. I mean, I think it's true. It's like as soon as, I've been on teams where we choose performance and then at some point we decide that's not a focus anymore. And like, unsurprisingly, performance drops rapidly. You would think
Right.
it's like, no, it'll be fine. It's like, no, like micro decisions happen on a day-to-day level where it's like, if I know it's someone like Alex who's like, no, we care about performance, we're going to run at this rate. When I'm writing some loop, I'm going to be like, does this loop need to be here? Like, should this be a map or, an array? Should this be a pointer or like for every decision, like as you write the code, like in the back of your mind, you're sort of thinking like, how's this going to run? And if someone tells you like, don't worry about performance, this is just a prototype. We're just trying to figure out market fit. And like, yeah, fuck it, stood map. Let's roll. Like people will stoop to the level unless you have like heroic level of self-discipline, but then it's discouraged. People are like, why are you doing these optimizations? Like, well, because I must be true to the performance. Like, but we were
Yeah, but
told
also for the prototype, right? Like if it's seriously a prototype, like the time's much more important than like your optimizations, right? So it's like unless the prototype is not hurt by
yeah.
the awful performance, it's kind of whatever is good enough will be good enough. So it's
That's, I don't know if that's true. I'm no, genuinely, I'm not trying to like go to it. Like, I think that sounds right, except in practice, what I've seen is every prototype is just put in the code. Like every successful prototype is just like, great,
that's the
right?
problematic part. Yeah.
Right? Because, everyone says, well, a good PM will give you time to clean up. And it's like, yeah, they'll give you like 3 days to clean up, right? because the subside of it is like, if it's good enough for the prototype, I think this is why it happens. Like, let's say I'm a PM and I'm like, oh, this is good enough for the prototype. You probably don't need like 100x improvement for it to be good enough for the product. You might need a 2x. And so why would they give you time to rewrite it from the ground up to get 100x when they can just ask you how many days will it be to remove the bugs and make it 2x performant? Like that's what they'll give you. They won't give you the thing that will, and by give you, I don't mean it in a mean way. Like that is what makes sense for the product. So if you don't take the performance early, there is no business reason for someone to give it to you. And so I get the argument that like, yeah, using, hash tables everywhere is faster and easier. But if you practice, it would be almost as easy to use arrays or something. right? You can practice your way. And I think like, if you watch like Casey do Handmade Hero, like he spits code just as fast as like Alex or like Inigo. You watch Inigo in the demo scene, he'll like spit code in an hour. If you practice to that level, you will write code just as fast as any prototyper out there doing it in Python or whatever. He will spit C that's performant as fast, right? Now, the question becomes, if you then give those people hash maps, can they do the prototype even faster? I'm not actually sure. That's the problem, is that like, I think they're already writing performant code at the speed of their thought of the prototype. And so in some sense, it's not actually faster. It's only faster if you haven't practiced writing it the performant way, is maybe what I would, maybe that's my intuition currently. Because every time I've like written some stuff in Lua and I'm like, wow, I got a lot done. And then I hit a performance wall and then I'm like, shit, I'm fighting the garbage collector now. And then I spend like, does anyone measure the time you're fighting with the garbage collector? I'm not sure. And so I don't know. I'm genuinely unsure if that's actually true. And then the other point is like, oftentimes the point of the prototype is performance. So like one of the things on Dreams that people do is like, they make scenes out of like these small pieces and they replicate them hundreds of times, right? They make like bushes and trees. So if your performance isn't there, well, then you build things fundamentally in a different way. And this happens on tooling too. Like at Google, there was lots of tooling for testing and analysis of tests, and there was lots of prints and logs and the analysis of logs and lots of tooling for this stuff. But if your code compiled in like a second or less, how much of that do you really need? Because you'd see the problem immediately. You'd have a debugger attached. Like people are allergic to having debuggers. Like, okay. And in code, you have a bunch of UI to tweak a bunch of debug values. Well, if you have live recompiles and your compiles are less than, like I think Billy Bassett made the same point. So like, just change the value in the code and then just recompile and then you see the value. Why do I need to add a slider? Like that's a real burden where it's like, you may have a whole system to do things because you can't do them at runtime efficiently or like so people often talk about like, oh, I want really fast compile times, and they can't like explain why that's so important very well. I think Billy did a good job. It's like, it actually removes a lot of tools you might have to write otherwise. Like, so it's a real savings, and you could feel it when you go from a system like on Dreams, we had live recompile. So you can just change stuff and it would do it. That was the other big thing. And so, you go to a system like Google where people are like, well, but how will you do tweaks? It's like, you just do them in the code, but the code takes a long time to compile. It's like, but what if it didn't? But the code needs a review. But what if it didn't? But the code needs to pass testing. But what if it didn't? If you remove all those, all of a sudden, right? It's like, all of a sudden you could just change the value, right? You could. And then people are like, it's too many things to change. So it's like, and these things also have other good reasons to exist. So I don't want to be totally, but like, maybe worth considering, especially for an indie person or somebody who's doing it themselves. Like, sometimes people are like, oh, I should do things the way the big companies do it because like that's more professional. Like sometimes those layers are there because a previous layer was there, and that previous layer was there because a previous layer was there, and so forth. And sometimes not always, you can remove quite a lot of layers. Yeah.
So we have one project to discuss yet. Your Gen AI adventure.
Oh yeah.
You coded with Gen AI assistant a game.
And, yeah. Leave the spiciest for the last.
Couple of weeks, right? Because when I've done this, I done like a small project, like in a very like with the Jules, the Google agent. Mm-hmm. It's like an agent that is sort of similar like Devin AI that is kind of like works as a sort of standalone thing. So you give it a task and you kind of forget about it, and then you come back after 15 minutes.
Okay.
So, but this was like very small, and it even like you could kind of like handle this. And then you said that you worked on this for like a couple of weeks. So I'm assuming code base grew. So tell me the story about this game, how it worked out.
Yeah. Well, the kind of preface to this is like, I've been working with artists for a long time. So I'm like very much on the artist side of Gen AI, like when that debate was happening and stuff. And I'm generally skeptical. Maybe that won't age well when the machines completely take our jobs in a year, but I'm like generally pretty skeptical. So like if someone asked like what game would Anton make, it would probably not be written in Gen AI with Gen AI used on the web with microtransactions, which is what I ended up writing because that's what happened. But like this is the opposite of what I did. But basically Adobe is nice enough to give us a sabbatical every 5 years we're there. So I got a month of sabbatical. Thank you, Adobe. So I was just like, I was originally going to finish one of my side projects. But I was talking to some people, and people always come to us and say, AI, like, we got to do AI. And I'm like, oh man, AI coding. And I'm like, oh. And so I have like opinions, right? But I was like, I was tired of like rehashing my opinions. And I was like, look, the thing I did at PlayStation was like, I took technologies like tracking technologies and I would make demos. So I'd make demos with like ultrasonics and acoustics and heartbeat monitors and eye tracking. So then I'd have like a real opinion, right? So I was like, I need to go back to like these roots, and rather than like be old man yells at cloud, like make something, right? So I'm like, what can I actually make with Gen AI? And like, let's do it in earnest, right? And then even if I sort of whatever. So I was like, okay, what can we actually make that's interesting? And I thought, okay, what if we I make a like a collectible monster game where the monsters are generated by AI. This was around ChatGPT image stuff, like where everybody was Miyazaki in the images. And I was like, I typed in, I was like, generate me like a collectible monster that has like flames and rocks. And it did a pretty good job. I was like, oh, this is pretty decent. And I was like, make some attack animations. And it made some animations like, okay, this is like making some sprite sheets or something. And I think there's better techniques, but I was like, okay, maybe I can do this. So then that was my idea. I was like, I'll make this game and people will make monsters and they'll battle them and they'll trade them and that kind of thing. And it will all be Gen AI. And like the names will be Gen AI, the descriptions will be Gen AI, the stats will be Gen AI, the battle will be Gen AI, everything will just be Gen AI. Like, cause I'm just like, let's just try it. Let's throw it at the wall and like, let's Gen AI all the things. And on top of that, I'm going to write it in cursor because like,
Gen AI.
cause Gen AI, man. So there was like my paradox. For some reason, I still don't understand why it happened, but I was like, I was going to have maybe it's because like on some subconscious level, like I'm going to have a break from like the real low level C++ thing. And I'm going to live this AI dream where I just type into cursor and it makes websites for me. And I know very little about web. Like I've made like little toy websites with like HTML and JavaScript, like vanilla kinds of stuff. But I don't know about the structure, man. And so I was like, all right, ChatGPT, I want to make a game. I like just wrote this blurb. And I was like, I want to make a website. And it was like, fantastic. This is a great idea. And I'm like, thanks, ChatGPT. I'm feeling real smart right now. And it was like, here's the sample structure. And it was like, we're going to use these frameworks. And I was like, hold, we will not use frameworks. I was like, I got to put an end to this. And I was like, we will use vanilla JS. And I was like, fine. Okay, we'll do that. And then it started doing it. And I was like, there's too much code. And he's like, I was like, yeah, that's right. Can we use Express? I was like, what's Express? I was like, I don't know what Express is, but give me an authentication phase. I'm like, please let me use Express. Like I was basically like begging to use libraries because it just doesn't know how to do vanilla JS. And that's like basically all I know how to read is like just, I have my index.html, index.js, index.css. Like, let's go. And I was like, all right. I was like, okay, give me. I gave it like a prompt where I was like, pretend you're an orthodox C programmer who is coming into the web and you don't want to use dependencies. What will you use to sort of set up this thing? And it was like, okay, we'll use Node.js because that's going to give us something for not a lot. And I was like, okay, fine. And we're going to use Express for auth. And I was like, okay, we'll use SQLite 3 for the DB. And I was like, sure, 3 is fine. You can have 3. You can pick 3. So it took those, and then it took like bcrypt or something for auth. And then it was like, and it spat out a web page, and it like, I had like authentication. I don't like, please don't crash my website. I'll give you a link at the end. Somebody will probably security ram this thing, but I'm a real person. but basically it set it up, and it was really cool in from like a beginner standpoint where I'm like, look, I don't really like, I actually want to learn this stuff. I like learning stuff if I work on it. Like that's actually, it brings me happiness, right? Um, but there is a sort of like, it's almost like a drug dopamine. It's like a cocaine hit. I don't really do drugs, but I would imagine this is what it feels like if you just got injected with a drug where like I just typed some words in and I got a web page with authentication. Like the noble part of me wants to learn how to do that well and maybe even write my own encryption, right? Even though that's unadvisable, but like that's what is actually like enticing me on a good level. But man, it's pretty cool to just say I want a website with an auth system and it's done. I'm like, and then I feel myself feeling like, well, all this stuff's kind of messy anyway. It's all dependencies on dependencies anyway. There's trash everywhere anyway. What's the problem with me adding a little? So before I was in this noble state where like my website will be pure JS because I will not submit to this like, and with Cursor very quickly I degenerate into like, yeah, just slam in another dependency, get that hand, like you rise to some level of abstraction where it's no longer interesting to you, for better or for worse. And I'm like, I don't know if I like this, but I was like, okay, this is now going to be an experiment because like I'm now feeling these feels. I'm like, you know what? Let's just like see where this river takes us. Because so then I gave it the design and I'm like, figure out the design, figure out like everything, like, and then let's just see. And so like it did a bunch of design work, do the art, why not? And I'm like, let's see what happens. And so like I let go of the reins for a while, and that was like the vibe coding honeymoon. And like in 3 days I had this website, and I was like, man, this is kind of crazy. And then of course none of it all started breaking down. Like it was a bunch of files, and it would try to like change something and then it would get lost. And then very quickly I felt like I can't do anything with it because I don't understand most of this code, right? Like I understand some bits here and there, but most of them, like it's doing some, weird syntax in JavaScript that I'm not aware of. A bunch of like promises are flying around. I don't know what the lifetime of anything is. I don't even, anyway, I don't know much of it, right? So I can't debug the problem. And so I was like, very quickly, you have to start learning what it did to try to correct it. And so in a way that was interesting because then I actually had to learn about some of these things. And then you'd go in and you're like, do you really have to do it this way? And it's like, no, you can do it this way. And so I cleaned up some of the code. So then I threw all of that code out and I was like, okay, I understand now. We need Node, we need Express. We're just going to roll with these things. And then to make, to your point, like a larger project stand up, I was like, I learned the buzzwords. I was like, all right, we're going to like have an SPA here. We're going to have some SSR here. We're going to have this on the back end. We're going to have this on the front end. And then it like all of a sudden I was like speaking its language, and then it got better. And so I separated the code in like overly structured ways. I'm like, this is where this code will live. These files, like everything that touches the DB is going to have a DB suffix in the JS. Like don't put anything that's that kind of stuff. And then I would ask him like, is this what web people do? Because I was just like, I have no idea. And it was like, well, this is a little bit unconventional, but I can see how it's going to be good. And there's like some people do it. I'm like, are you just lying to me to like make me feel good? I don't think anyone does. It's like, well, it's not common, but and I was like, all right, we're rolling with it.
You broke me.
Yeah. So how does this sound? I'll take a pause here. Like, is this total madness? How
This is like a downward spiral I wouldn't expect from you. Like, oh, here I'm on Project Dreams. We do this the hard way.
Yeah.
We do this everything from scratch. It's like, let's go, Cursor. You're my bestie now. Is this something okay?
Yeah. Yeah.
When did you like 30 minutes ago? You were like, oh, checking in, go how to Google. It takes so much time, and you're now obsessing over a suffix in your file. Come on.
Well, because without the suffix, it would just put shit everywhere. It didn't know what to do. Like it didn't know. Like the performance was literally better if you named things like how, well, either how web people, I still don't know how web people name things, but either how it preferred to name things or the schemas that I created, because like then it kind of knew like this is where this goes, because you have to communicate to it somehow, I think. I mean, I'm still, I don't know if it's, people say it's like a junior engineer. I'm not like, it's an apt analogy in some ways, but like not. And then it makes sense. Like all, like what you said before about like setting up the constraints such that people won't screw things up. Like that is a thing that companies like Google do. So that when you have tons of employees and nobody can vet these employees effectively and they're at different levels of skill. Again, no shade, like I wrote crap code, but like I sort of came up in an environment where the crap code shipped and then you got yelled at or like it made it into the repo and someone said, dude, what is that? And you're like, ugh, sorry. And then they teach you, right? But if you come up in an environment where like when you write crap code, test silently fails and you learn basically by like Pavlovian like slaps on the wrist from the computer, well, then that's the same structure that works very well for LLMs because you set up these tests and you set up these code structures and you slap it on the wrist. You're like, no, don't put database calls. And it says, oh, I'm sorry, I knew that. And so I wrote like these conventions files and I just prepended them to cursor. I'm like, here's how, if you do database work, this is what we do. This is how we name things. This is how we comment things. And very quickly, I did all the practices more or less that Google does because it's like, that's how you codify things. And it's interesting, like Media Molecule had an explicit anti-coding guideline, which is another kind of maybe quirky thing. I came in and I was like, even me with like some background, I was like, I was looking at the, I told Dave, who was like the gameplay director, and I was like, Dave, I looked at the code and I was like, there's different styles, some code is camel case, some is snake case, some people use like K&R braces, some people don't. And he's like, yeah. And I was like, well, what's the code style? Like, I want to be, probably some of this is legacy and we're trying to like, what's the latest convention? He's like, there's no convention. Like, what do you mean? It's like, yeah, just write the code. And I'm like, okay, but maybe we should do a convention. I was like, maybe I'll be helpful, because I'm starting and I'll, maybe it's, maybe you and I can work on a convention. Right? He's like, no, we're not going to do that. I was like, what do you mean? He's like, look, just be a chameleon. Like if you're in a snake case function, write snake case. If you're in a camel case file, write camel case. Like just don't mix too much, but otherwise, like just don't do it. And I was like, and I just kept pushing and he was like, look, just don't waste time on this. It's a big waste of time. And that was the feedback. We don't have a convention on purpose because either you have convention discussions and then you end up with a doc and then you don't discuss it, or you say no, it's like forbidden to discuss. Like that's actually a choice, and that's a choice that we did on Dreams, and the code looks maybe bonkers by some people's standards, but it has some interesting side effects. Like I know the code that Dave wrote because it looks like Dave. But anyway, that's the stuff you want to purge when you're working with an AI because the AI can't, it can't handle it. It's like it just gets confused. And a lot of the stuff it trips up on is like, oh, in SQL, like the database is snake case by convention, but then like you return the variable as part of, the get request and like it's camel case in the JSON, but like there's no static checking. And so like it just makes stupid mistakes like that where it like copies the variable directly out of the DB, keeps it the same way. And then the casing like across the wire gets muffled. And then I'm sitting here like printing crap out of the console and being like, what? Basically, I was like trying to stay out of the loop as much as possible. And I would be like, doesn't work. Here's the console log. And it's like, oh, I see the problem. I renamed the variable. I'm like, what can we do so you don't do this again? Right. That was basically so I was like very project management level. And so, yeah, you end up with these conventions. So like, I don't know, maybe in a way, like people resemble the technology or vice versa or something. So I think like strict guidelines and tests, and you ask it to write tests and it tries to, I actually still didn't do any testing even in this thing. I just kind of like let the logs roll and fed the logs to the cursor. And so So with that in mind, like I ended up having to do like the architecture, which is like basically saying what's going to be what, and then it keeping it on the rails within a few files. But then like Claude 4 launched midway through this project, and everybody was raving about it. So towards the end of the project, like I just finished a few days ago, so I set a limit. I'm like, I have 30 days. I'm just doing it. So I worked like, I didn't go crazy. I worked 8-hour days like for 4 weeks and just, and most
You
because of the early bring up is like so much code and so much boilerplate. I totally get why now people in the web world are way more thrilled about like AI coding than people in the C world, because there's just flat out so much boilerplate you have to bring up to get like, and not all of it is like web slop. I think a lot of it is just like you're fundamentally running a client server thing, anything in web, right? There's some kind of version of a client and server. In games, like if you're writing a toy indie game, you don't have to worry about the network at all. But even in a simple web app, you have to at least be conscious of the fact that like there's some kind of requests flying back and forth, right? And so there's some kind of API management. In a game, you could just push pixels to the screen. So in some sense, games are a simpler stack in some sense, you know, unless you do multiplayer or whatever. So I get it. And it's like CSS is kind of a mess and there's no good defaults. And, you know, you can write a game with IM GUI and like your buttons look like buttons, at least in CSS. It's like, oh God, why is it in the top left? Like, this doesn't make any damn sense. And so anyway, towards the end of the project, I was like throwing Hail Mary calls to like Claude 4. I was like, Claude, we're at a deadline. We have one more
please.
day. We need this web page. You really got to do this well, man. And it's just like, give it full context, you know. I spent like, I think $15 on cursor credits, like in the last day, just asking to do like major overhauls. And I didn't version any of it. So I would just let it roll and just reject if it didn't. So there's like zero version control. I just rolled it through.
What is the end state then?
So there's a game. You can check it out. You can go to like it's a monster. It ended up being a monster sumo game. So you can go to monsumo.tv, and there'll be monsters battling. And so there's like a little TV, and you can hatch monsters. You get like eggs, and you hatch them, and in the back end it will call like image generation APIs, and it will generate these monsters for you, and it'll generate some stats, and then you can enter them in the arena in the battle, and then you get gold, and then you use the gold to buy like more genes you can put into the egg. So it's a very simple game, but it's sort of like as an experiment touches all the Gen AI things. There's problems. So maybe the problems are more interesting technically. There's a big production level problem that I hit early. As I wanted to just use this tech and I wanted to just generate monsters, but very quickly I realized that cost me money. I didn't realize, well, I mean, I kind of realized this, but I didn't realize how much money it costs. And it costs enough that I can't just like make it free. So I ended up by accident making a microtransactions game because I have to pay for the back end of the AI. So then like I had this like lived understanding experience. I was like, the mobile devs, they're not all totally evil. This is just the world in which they live. I'm like, well, look, I'm running the server. Every time you hit the server, it spends like a few dozen cents to like make some stuff for me, or like for you, really. So I take like no cut. I take like a minor margin to keep the server operational, and the Stripe takes a piece, right? Everybody takes a piece in the world of the web. And so like very quickly you're like, this game simply can't be made if I don't charge anybody for it, unless I'm like OpenAI or something and I'm just like bankrolling it at a loss. So I'm like, okay. And I was like, ChatGPT, what's the design? Like microtransaction. Like, fuck it, let's roll, man. Like we're doing this. Like we're on vacation, buddy. Let's do it. So it's like, you know, it's like 50 cents or a buck an egg or something. And so every egg will ultimately pay Stripe and pay other people to generate these images for you. And then you battle them, and then the text is generated. I think I think it's kind of, I really wanted to see like, can you use the Gen AI as part of the game mechanics? And I think, so I wanted to push it. Like the proper design would have been like, give everybody standard monsters or something for free. Like there would be like the free to play model. So you get like some free monsters and you don't charge anybody. And then like for people that want the unique monsters, you like pay the money, and then
the AI generates it. But I was like, that's boring. I'm trying to make an AI game. So like, I want to like live the technology to the fullest. And like, the cool thing is I take these two monsters and I can breed them and use the AI. Like I can make anything. I can make like a rocky, feathery snake. Like, why not? That's cool. So like the closest thing to that is like Spore, right? But then you have to make it. But here it's like, I just have this power fantasy of like, I throw in some genes and it's kind of like a slot machine. It's basically an AI slot machine, right? So it's no big, no high moral ground to stand on, frankly. I think in this project, but as an experiment, I think it's interesting. But also just to see practically when people are hyping this stuff, like, can it actually be used? And I think it's, in some ways, it forgetting all the moral aspects of generating the art rather than paying actual artists. The quality of the art is interesting in some way, but like a stupid fundamental problem is like, I have these monsters and they're battling like this or whatever, but it can't reliably generate them facing in a given direction. So if you try this prototype, like 1 out of 10 times, the monster will be backwards. And I have no clue because I just kick off a request. It gives me an image. I don't know. I'm not doing image analysis on these things. So like and I actually tried to feed that image back and have it analyze the image and tell me which way it's facing and then flip it. But it costs like even more money to analyze and it's still wrong like 50% of the time. So you can't like, if you're doing it for your own game, obviously you just flip it. But if you want to run this as a service, it's like pretty unreliable. So I actually have an admin page where I have to flip people's monsters manually. So my job as the admin is to basically moderate the AI slop coming in and make sure it's facing the right way. I don't know.
How many monsters are you having then?
Well,
you have an admin page?
I don't know. I mean, this is the day of the launch, so I don't know how many users I haven't checked. But basically everybody gets a unique monster. So you, for the small fee of, whatever dollars per egg, you will have your own unique monster. And it's not even an NFT. It's actually it's in my database that's securely guarded by code that Cursor generated, that you truly will own this monster and it will be truly yours and unique, which I think is kind of interesting. As a concept. So I was like, okay, let's like play with that. And then, so that's where it's at. But like, as a matter of like actually coding with AI, like, I mean, it got frustrating when it couldn't fix things. I didn't like the latency. It really hurt, I think, when you hit polish, when you're just like, hey, I just want to move these things around and detail stuff, and so much of the game polishes details. And if you, it made it obvious for me because again, I'm not well versed in this kind of code, so probably you could go in and be like, oh, I'll just change the CSS to like get rid of this drop shadow, but I'm not even sure where the hell the CSS is because I didn't write it and I'm not that good at parsing these files quickly. So I just end up sending stupid requests like, Cursor, there's some CSS on the monsters page. It's in the top right.
Find it. Find it, please.
I don't want the drop shadow. And it like deletes it and then it changes the font. And then I get like, the only recourse is that it tells me where it changed it. So I can click on it, aha, that's where it did it. And then I can like noodle in there. And then sometimes I just write code like almost in C because I can write JavaScript barely, but I'm just like, I'll write some crap JavaScript and be like, Cursor, I wrote this JavaScript. You know me from my profile.md doc that I'm not a JavaScript writer. Please fix this to be idiosyncratic, or like more idiomatic JavaScript, and it will just like rewrite it. So I wrote like, and then I made like little files that it can't touch. So like the actual battle system between the monsters, I wrote it in pure raw JavaScript, and it just has like a couple of exports. Nice. And that was my playground, and everything else, nice. The entire thing is like, it's Cursor. So I don't know if I'll do it again. Frankly,
you don't know. You didn't like it. Overall,
I didn't. I do pottery, and like I like making things out of clay. And like maybe 100 years ago, I could have been like a potter, and I would have, well, not 100 years, like maybe 1,000 years ago, whatever. And I could have made pots and sold them, right? But then since then, we have like factory made pots, right? and those are cheap. And it's like impractical for me to live as a potter. I think the same thing might sort of start happening where it's like you might enjoy the craft of coding, which is like me and like other people in the code camp. And the people making this AI are like making effectively a factory for code. And so what, in a way, they're sort of saying something, they're trying to respect the current craftspeople and say, look, you're like one of the best programmers, et cetera, et cetera. You should be at the forefront of this pottery factory revolution. We will put you in charge of the assembly line for these pots because you are an accomplished potter and we don't want to leave you behind and we don't want to lose any jobs and all that good stuff, right? Like forgetting any of the capitalist sadness. It's like, this is the truth of it is like, we've now got factories and we want to use the current. And I'm like, dude, I didn't become a potter to manage people, I became because I like clay and I think it feels nice and it's like sort of chill and I give it to my friends or whatever. So that's how I feel about this. And like, yeah, you know, maybe I'll be 100x coder, but it's like, but I like typing the things in and making the pixels change. It's like, you end up having to be, I don't know, it's something like a project manager, but I'm not even sure it's quite the same. Because if you know, I've been like a lead on things and it's like, at least you're still interfacing with real people. You get the satisfaction of talking to real people. Like, hopefully they respect your leadership and direction and you're trying to motivate them and they're enjoying that part and you're kind of together, you're in a band or whatever. But here you're like, it's fake motivating you by telling you your design is brilliant. And you're fake motivating it because you're like, please do this. You'll be very important. And it's like, what are we doing here? Like, what's actually happening? And I don't know. It's kind of real because you could feel like when you talk to ChatGPT, if it like praises your thing, you're like, maybe this is a good design. You're just like, shut up, dude. Like, this thing is just stroking your ego. Stop.
Yeah.
Is that sort of echoing your foray into this field? Like, I'm curious as a experienced web tech person.
Yeah. For example, the last thing you mentioned that like whenever ChatGPT or other models will compliment you, you kind of like, yeah, it's human. You take this like at face value to say, yeah, it was my idea, you know? It's like you need a second to realize that's like it's kind of programmed to do that. And even if the idea isn't that great, it will tell you that it is great. So it's kind of fake. But yeah, with a lot of the things I agree. I think we mentioned even before we started recording that like you mentioned that you have a low understanding of the code base in general because it was generated. I find it infuriating.
Yes.
Because then I have to, like, the code stays. I need to work with it later on. It's so difficult. And at some point, like, I don't even know whether it's quicker, you know? I generate stuff. It's great. If I do this, I did this for a new library, actually in Qt, the C++ thing. It's like, great. I didn't know this. I generated this. It's great. And I have zero memories of it. If I need to do it again, I'm starting from scratch. Either I'm learning it or I'm generating it again. So it's like, I would like some of it to stick more. And, you know, but maybe that's the thing, like this job shifts now and you're kind of becoming a manager of a factory, clay factory instead of a potter. So it seems like so yeah. I have one question. One question. Last one. Yeah. Because I think you're gonna break the record for the longest episode. I think it's held now by Jonathan Blow. 3 hours. And change.
Coming after you, John.
So we're over 3 hours now. What is your opinion on the new low-level languages like the Zig, Rust, Odin, maybe?
Yeah.
Like you spend so much time in the C++ world, knowing this by heart, and you know, on one hand replacing it with a new thing, on the other hand, you know how many caveats there are in these languages, especially modern C++ or just the raw C, and some things that are fixed just like through the modern approach. So what do you think about them?
I mean, I think when I look at like stuff that like Bill says about Odin or John says about Jai, like I agree with all of it, like 100%. Like, pretty much every sentiment. Maybe if you get down to the details of like this feature or that feature or whatever, I can find some like bike shedding level of opinion. But all of them are like, yeah, it has to compile fast because iteration speed's fast. It has to be statically type checked because like that's great. And then obviously C syntax ish, except like there's nothing too wrong with it except let's fix some of the cruft, and no one likes headers, so like let's maybe fix that part. And like it sure is nice to have some reflection so we can do serialization, because that's a major pain. Like you have to do macro hell, and macros are awful to debug. So I kind of wish I had, more time's the wrong word. Like I want to say more time to play with them, but like I could play with them more, frankly. And I play with Jai a little bit. I really like the speed of it, like the the general like philosophy and stuff. And I read the Odin docs and they look great. I don't know why I'm not using them, frankly. It's like partly because I think maybe because at work I'm using C++, and so if I code at home, like no, I feel like ultimately like C++ is just not that bad. Like, well, okay, it is bad. I haven't quite hit the level where I mean, I suspect, I don't know the state, but I suspect I have had moments where I get so fed up with C++ where I'm like, you know what? I'm going to rewrite an extension on C. And like, I've literally started, I have a folder where I was like, okay, this is going to be my C+, right? And like, what's my wish list? I just want like some reflection so I can, serialization sucks, headers suck, like a few kind of, everyone's got their pet peeves, but there's some common pet peeves that people are trying to solve, especially with Zig. Memory management is not one of them. So like, I'm fine with the memory management. Like it's not a problem. And so I think my opinion is like favorable on all of them, but I feel like the thing that would make me switch is probably the same thing that would make me write my own. That's, like I have to be so fed up. And by that point, I'm so fed up that I'll probably have the motivation to start my own. But then like clearly that's a bad idea, especially now after like very smart people like these folks have already started their own and they're all pretty good. So then I have to be like, check myself and be like, really? I mean, like Odin's pretty good. Or you can, Odin's out. Like Jai's maybe not out yet. Maybe doesn't have much docs or whatever. But like, whatever. Like they'll be great. They'll all be great. Why do I need my own? So then I have to contend with that. And I have a lot of code that I've written in the past that like I sit on like for personal projects. I have tons of games and things, just like prototypes, not actual like full ship things, but like just tons of code that I can pull from. I think Jai has some capabilities for like translating that code in like automatically. I think maybe Odin as well. I don't know.
There's a binding generator in Jai that can create bindings for
though. Like that's just like
stuff.
Yeah.
But I don't think there's like a dynamic regeneration module.
Okay, because basically like if I have a bunch of code that is like, just orthodox C++, right? I don't really want to I don't have libraries that I want to bind necessarily. What I want to do is just like convert the code, because then I'll just have like code that I understand and use. Like I have, having done a bunch of these side projects, I have like just simple code that is no smarter than anybody else's code, but I understand. And so like stuff to load shaders, stuff to tessellate this or that, right? And it's like some drawing routines or random stuff. And like, I generally prefer to just use that stuff because then it works. And also I just prefer writing code over reading docs unless there's a big win for that. And oftentimes you bring in a library and then you get some losses. And so I'd really like it to just like change my code. I would also trust most of the code, obviously from John's probably also really good. So I should probably just use that if I'm in Jai world and Odin world or whatever. I have very little experience with Zig at all. Like, so I think it's just that momentum. But if I was to start now, I'd probably definitely give those a shot. It's hard because there's just so much legacy code that is not bad, and I think obviously like I kind of lurk in the Jai community, and I see like lots of people have ported a lot of the what do they call, like the unofficial C committee approval code, like the STB libraries and IMGUI and all these things that are okay, that we know are okay. We're allowed to use these things socially. So maybe there's enough of a there'll be enough of critical mass of that code. But yeah, it's hard. I mean, as sort of into rewrites and things that I am, like if I'm doing stuff on the side for hobbies, like I've got like a limited hour, maybe a day or whatever to work on this hobby thing, I got to be pretty brutal about like, and so I get the urges to just use stuff. So I don't know, maybe just different urges. I don't know. It's hard. Yeah.
Okay. Anton, thank you so much. This was awesome.
Great time. Thank you.
This was awesome. Can we plug your things? First of all, what's the URL for the game?
It's monsumo.tv. So it's like Monster Sumo, monsumo.tv. So this goes live in like a week. So I have a week to fix the code before.
This will take a couple of weeks.
So hopefully by then
get edited. So you'll have like a week head start. Hopefully by then it is not broken, because like you launch it. A week. Yeah. Okay, and then you're on X, right? Yeah. You can follow. People can follow you on X.
Antovsky on X, but you can put it in the description. And I don't really post much. I kind of lurk, but I don't. Yeah. You can DM me or whatever, or just message me, and I'll reply. But I try to stay off social media as much as I can. But nobody seems to be. This seems to be where life is headed. So can't resist it fully. Yeah.
Awesome. I mean, not awesome on that part, but generally
it's life.
Awesome.
Thank you, man.
so
It's been
much.
A big pleasure.
Thank you so much that you joined me.